Haloalkanes and Haloarenes. Welcome, Vanakkam, Suswagatam. This is your Baba HSP. Good evening to each and everyone. Today's slides, the homework, each and everything is going to blow your mind. The thing which you are unable to understand, today you will understand each and everything, kids. Super amazing session is going to be conducted over here. The one who was unable to understand this chapter, each and everyone today will be able to understand. Each and everything is going to be marvelous, super awesome. But kids, first of all, I want to see the fire symbol. You have to register, you have to smash the like buttons. Yes, hit it. Today you will see how this chapter look like. Yesterday for 6 hours, I have given 6 hours. I never made my notes for my MTech, but I have done this homework for you people. Everyone was saying, sir, this chapter looks very, very tough. Idiyappam Muruku. I said, kids, don't worry. I will make it Romba Sulvam. This chapter, alkyl halide, haloarenes, haloalkanes, looks like chemistry pedicure adu customer. But I want to say, it's Romba Sulvam. So I want to see your Josh. Somebody has written that, sir, why you kept the session timing from 7 kids. I'm taking here in Jaipur offline advanced classes. My class gets over at 6:50. Now kids, this is the only time from which I can start. My dear students, really how much homework I have done for you. You can see these slides. They will tell you that how much homework Baba has done. See kids, see, you are going to enjoy each and everything. But let me tell you that you have to watch and understand each and everything from the beginning. Are you ready, kids? Let me see that. Is everyone ready? Kids are ready. Today you will see that what is chemistry, kids. Definitely, definitely, definitely you are going to enjoy this lecture. So let me come over here. Let me start from the very beginning, kids. First of all, let me tell you who am I. Okay, my introduction I will tell you later on. But see, this chapter is haloalkanes and haloarenes. Are you ready, kids? Now see, everyone. This is the backbone. I think a little bit it is visible to all of you. This screenshot I have taken from my NCERT. 20 years old NCERT. I have taken this screenshot from over there. It's written elimination versus substitution. This is the backbone of this chapter. Now, some of you must be thinking, sir, if we don't know about hydrocarbon, whether we will be able to understand. Everyone is going to understand this chapter. Everyone, each and everyone, you will understand each and everything. So first of all, I will tell you the backbone of this chapter. That substitution versus elimination. This paragraph. This is one paragraph, but it will need too much time. Quality content to understand it. My dear students, let me tell you one thing very, very properly. If you are able to understand the how and when to do substitution, that is SN2, SN1, E2, E1, sometimes along with SN2, E2 is taking place. Sometimes along with SN2, E2 is not taking place. Sometimes only E2 is taking place. Sometimes only SN1, sometimes SN1 and even both. This is the confusion of each and everyone. But my dear students, I will solve. I'm giving you guarantee kits after my teaching. Only after 1 hour you will be able to say that in this reaction along with SN2 and E2 will take place. In this reaction only E1 will take place, and in this reaction only E2 is going to take place. This is my promise. I will give you at the last, means after 1.5 hours, one chart, and then I will give you questions. Each and every one is going to answer it. Then you will say, yeah, it's looking like easy peasy lemon squeezy, done and dusted. But my dear students, we have to go first step by step, and you have to tell me how many of you are having this type of confusions and you've never got that accuracy that when SN1 will take place, when SN2 is going to take place, when sometimes only E2 is going to take place. If this is your doubt, then I want to see fire symbol in the chat section, and today I'm going to tell you each and everything. So if this is your doubt, then show me some fire in the chat section, then I will give more importance to it. If this have been your doubt, this would have been your doubt, and still it is your doubt. Yes, kids, let me check it out. Let me check it out. What kids are the symbol they are showing, kids? Okay. Now, this is our target. The first target is elimination versus substitution. And to understand it, let's start this substitution versus elimination. Okay? Okay? Okay. See. This is Bunny. Its name is Bunny. BN. Why its name is Bunny? There is science. Why the name of this girl or boy, whatever, it's BN negative. I will tell you, and you will understand why its name is BN negative, but it is having charge. Charge is like disease. A positive charge, if you are going to eat less, plus charge. Kwashiorkor, marasmus. And if you're going to eat too much, diabetes, that is also disease. Remember that anything, any form which is neutral, that is more stable than the charged form. Negative charge, extra electron, charge is like disease, and if somebody is suffering with the disease, what that person would need just to get freedom of that charge. So neutral form is more stable than charged. Only one slide, little bit is written that anyone who is having negative charge, that entity would like to neutral, want to become neutral, want to get rid of that charge. Now, how to get rid of that charge? If something, that negative charge entity is going to get positive charge, going to meet with positive charge. See, da-da-dan. Neutral form is more stable than charged, then BN negative wanna somebody positively charged. So this BN negative is searching for that somebody who is being positive charged. Now, do you know anyone who is having positive charge? Do you know anyone who is having positive charge? So see, in front of this BN negative, in that town there was somebody. Hey, this is saying, hey, I'm having H plus. Are you interested in my H plus? And this is saying, hey, I'm having carbon plus. So BN negative, Bunny, its name is Bunny. Bunny has seen, oh, wow, H plus, yay. Now just seeing this positive, Bunny started loving, oh my love, oh my love. Oh, Bunny is interested in proton. Bunny is interested in carbon positive or partial positive charge. This point is clear to each and everyone. Now just see, let me sit over here and do let me know Bunny is interested in whom? the H plus, or the bunny is interested in carbon plus? 2. Let me know, bunny is interested in whom? Bunny is interested in both. Now kids, bunny is interested in proton as well as bunny, because kids, remember that whenever there is solution, there is no one bunny, there will be millions of bunny. If I write 1 mole, if I write down 1 mole, if I write down 1 mole means how much? 1 mole means 6.023 into 10 raised to power 23 bunnies. These will be many bunny, many H plus. If I write down 1 mole, this will be how much? 6.023 into Avogadro's number, that's 6.023 into 10 raised to power 23. Many people. These are also, if I say 1 mole, that means many. Many bunnies, many H plus, many carbon plus. So somebody will go to this H plus and some bunnies will go to this carbon plus. If this is going to reach this H plus, people will say you have acted like a base. Once the bunny is going to form a bond with H plus, everyone will say, bunny, you have acted like a base, you have played your role like base. And if bunny is going to react with carbon plus, everyone say you played the role of nucleophile. So the one who is having negative charge, simultaneously it is acting as a base as well as nucleophile. Every nucleophile is a potential base and every base is a potential nucleophile. That means if any entity is having negative charge, so it will show parallel reaction. If I talk about chemical kinetics, you know that if any reagent is going to attack on the substrate, it will show parallel reaction, substitution as well as elimination simultaneously. See, in the starting I have shown you that there is substitution versus elimination. Both are taking place simultaneously. How to find out? Once the teacher is teaching you substitution, then he is not teaching you elimination. Once the teacher is telling you about elimination, he is not teaching about substitution. But both are taking place simultaneously. If you have seen movie, there is entry of Champa, heroine, car on car. Now, that heroine started dancing, ding, 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 ding. Then again fighting started. Now 15 minutes have gone. You are waiting. Where is the hero? Where is the hero? Hero is also there. But if you don't know about movie, you will say, oh, only heroine is there. Are you getting my point? Small hero, small heroine, studying in class KG. They were going to school together. Then the movie says 16 years later, then they are showing heroine only. You are waiting for the hero. Are you getting my point, kids? Everyone, are you getting my point? Now, the same thing they are saying, that base and nucleophile both are there and they are doing their work. So see, this is attacking on that and this is attacking over here, acting like a base, acting like a nucleophile. Now see, if the bunny is acting like base, then bunny will be responsible for doing elimination. And if bunny is acting like a nucleophile, then bunny will do substitution. And attacking on proton is known as acting like a base. Attacking on carbon is known as bunny is acting like nucleophile. Remember that. Now, see. This is attacking and this is attacking over here. Now see, acting as a base, this bunny can attack on H plus in a single step or more than one step. So here acting as a nucleophile can attack in a single step or more than one step. That This elimination can be possible in a single step or multi-step. This substitution is possible in a single step, multi-step. Now let me check, kids, you are able to understand or not this way, because this is a new way. I tried my best, kids. First of all, do let me know that you are getting it the way I am teaching, because kids, I thought of making it a little bit different way, but first of all, do let me know, kids, you are able to understand or not. This way is good or not? You are really understanding in a better way? If yes, I want to see, kids. Bunny, I will tell you, somebody who's having negative chat, that is Bunny. Why the name is Bunny? Everyone is asking who is Bunny. Everyone is asking who is Bunny. Should I tell you who is Bunny? Okay, everyone is asking who is Bunny. I will tell you who is Bunny. See, why its name is Bunny. The question arises, why its name is Bunny. See, kids, why its name is Bunny. Its name is Bunny because it can act like a base as well as it can act like a nucleophile. That's why this is imaginary. Yesterday night only I tried it out to make Bunny. What name should I keep? The character's name. I kept Bunny. Why I have kept the name Bunny? This Bunny can behave as base B. It can behave as nucleophile at the same time. That's why its name is what? Its name is Bunny. Dual behavior. At the same time, it is acting like a base. At the same time, it is acting like a nucleophile. Everyone, the character's name, why Bunny is there? It is having dual personality. Simultaneously, it is behaving as a base as well as a nucleophile. Kids, are you getting my point? Everyone, the name, why the name is kept Bunny, you got. Now see, single step. Single step means elementary reaction. Multi-step means complex reaction. Even if you don't know GOC, don't worry. I will let you know each and everything. This Bunny acting as a base, doing elimination reaction, acting as a nucleophile, doing substitution reaction. Single step reaction always means elementary reaction, and multi-step reaction means complex reaction. Complex reaction can take place in one step, two steps. No, not one step. Remember that complex reaction, more than one step. If it is being one step, then single step reaction, elementary. More than one step, complex reaction. I think you got it. You are getting it. Everyone is enjoying it. Now see, kids. Now see. Single step elimination is known as E2. E2. Multi-step elimination is known as E1. Single step substitution is known as SN2, and multi-step substitution is known as SN1. See this slide. Everyone, every point will get cleared. What is the meaning? What is the meaning of each and everything? I am going to tell you multi-step, single step. Single step is 2. Why 2? I will explain what is the meaning of 2. See, kids. This is a reactant or substrate. What is a reactant or substrate? Remember that. Let me define what is a reactant or what is substrate. The meaning of reactant or substrate. Just see, kids. Reactant or substrate, reactant or substrate is an entity whose carbon is involved, whose carbon is involved. Carbon is involved in reaction, that is bond formation, that is bond formation. That means if I talk about organic chemistry, that it means substrate, that is a reactant, substrate is always organic, is always organic. Remember that. Wherever it is written, it is always organic. It is going to be always organic. Reactant or substrate, this is always organic. That means it must have carbon. And the reagent can be organic or it can be inorganic. Remember that. But this is always organic. It is always organic. That means this can't be reactant. Reactant is always organic. Now see kids, this H plus is reacting with this negative charge, something reacting with the negative charge. Now my dear students, one thing, H plus can also be reactant. H plus can also be reactant. How? See how. That if any carbon is having, this is the carbon and this is holding H plus. It is holding H plus. So it's carbon and this negative. That means once the H plus is going, so its carbon will be involved in bond formation. This carbon will form bond with this negative. So it can also be substrate. Anybody whose carbon is involved in the bond formation, that will be known as reactant. So reactant is always organic, means carbon containing what? Carbon containing. And this can be organic or inorganic. Now see kids, if it is reacting with this, it is going to form alkene. Either the path E2 or E1. That I will tell you just after this slide. And it is going to react with this. It is going to form ether generally. That means either the SN2 or SN1. Right? One step or multi-step. Now see kids. This can be E2, E1, SN2, SN1. Now see, what is E2SN2? It belongs to chemical kinetics. You know, you must have studied chemical kinetics. 2 means it follows second order chemical kinetics. What do you mean by second order chemical kinetics? Second order chemical kinetic means, let's read one by one. First let me tell you, then I will read whatever is written over there, right? 2 stands for second order chemical kinetics. Second order chemical kinetics means rate of reaction depends on the concentration of both, that the reactant as well as the reagent concentration. The power of reactant is 1 and the power of reagent is also 1. So overall it is going to become second order reaction. The overall order of reaction is going to be 2. That means this reaction is taking place in single step, and single step both the reactant as well as the reagent are involved in the rate determining step. That means this reaction will not move with the formation of intermediate. That means no intermediate is going to form. No intermediate means no rearrangement, no ring expansion, no hydride shift. See, both E2, SN2, wherever 2 is written, both follows second order kinetics. This means that in rate determining step, both the substrate and reagent are present. Rate is equal to rate constant. K is known as velocity constant or specific reaction rate. Substrate power 1 and reagent power 1. 1 plus 1 will become 2. So overall order of reaction is 2. I hope this is clear to each and everyone. Just see if yes. Don't forget to show me kids the symbol of green symbol. Don't forget kids. If you're not able to If you are not able to understand, then do let me know, or if you are able to understand, then I will teach reactions after some time, kids. I will teach reactions after some time, kids. I've tried my level best to show you. Kids, you are able to understand Saucy. Yes, Saucy is there, kids. Or now, kids, see. E2SN2 both follows second order kinetics, takes place nucleophile reagent. This, so no rearrangement, no intermediate is formed, takes place in single step, no intermediate is formed, no rearrangement, no iodide shift, no methyl shift, no ring expansion, nothing will take place. Now, on the other hand, if I say SN1 even, this both follows first order kinetics, whether if I write down SN1 or even, one means first order chemical kinetics. They will take place in more than one step, take place in multi steps, intermediate formation takes place, so rearrangement may take place. May means either can take place or cannot take place. If they are getting more stability, then definitely they are going to rearrange. Rate of reaction depends only on substrate, so R is equal to K, substrate power 1, but reagent power is 0. 0 doesn't depend on the concentration of reagent. Now see, kids, for alkene formation, high temperature is good for elimination, and for substitution, low temperature is good. Why, kids? Why? I will show you with the help of reaction. Why for elimination high temperature is good, and why for substitution low temperature is good. Now see, kids, let me check it out whether reactions I have written why this is going to happen. So let me show you. Let me show you, kids. Just see. Now let me start writing. Let me start writing why the elimination high temperature is good. Why for elimination high temperature is good. See, kids. If I write down this reaction, CH3, CH, Br, CH3, and if I write down C2H5, ONA, C2H5ONA. I have written like this. Now see, this Na plus is interested in Br negative. So definitely this Br negative will go along with this Na plus. Gone? So this carbon is having partial positive charge. Now, kids, what this O negative is going to do? This O negative can behave in two ways. One is can behave as a base. Second thing can behave as a nucleophile. Just see, kids. Both the two ways I am going to tell you. If this is acting as a base, so it will take proton from here. See, let me write down the reaction as a base. As a base, it is going to behave as a base. Then what you will see, CH3, CH positive, CH2H, this base will take away this proton, C2H5O negative, and this will go away like this, and negative positive is going to form a bond, CH3, CH double bond, CH2, elimination. Now, kids, NaCl, one we have got Na, Br, one we have got this alkene, and one we are getting this alcohol, C2H5OH. Now, how many types of reactants were present? Reactants were of two types. Reactants were of two types. Products are of three types. Products are of three types. Kids, now see, these are three types. They are only two types. So the entropy has been increased. If I talk about entropy, then final type of product are three type, and these are two types. 3 minus 2, that is delta S is positive. Delta S is coming out positive. Now, if you talk about This sigma bond has broken, one more sigma bond, two sigma bonds have been broken, and one pi bond has been formed. That means energy required is more and released is less. So overall it is endothermic reaction, kids. Endothermic reaction delta H is positive. Now kids, if I apply Gibbs-Helmholtz equation, you must have studied Gibbs-Helmholtz equation, delta G is equal to delta H minus T delta S. This is positive minus, and the temperature is in Kelvin. So temperature is in Kelvin, always positive, and delta S is positive. So this magnitude is coming out positive, and negative into positive will be negative. But delta S, final delta S is positive. So kids, this magnitude is coming out negative and this is coming out positive. That means delta H is saying this reaction should not take place, because delta H positive means non-spontaneous, and delta S is positive and this is negative, so that thing is coming out negative. So delta G we need negative, and to get it negative the temperature should be very high, because whatever the magnitude, if I say delta H is 500 and this is also coming 500, then negative and positive will get neutralized and this will become 0. But we need delta G negative. That means to make it negative, temperature should be higher. If you are increasing the temperature, then this value is remaining 500, suppose 500 joule, and it is going to become 1500. So the negative magnitude will increase and delta G will come out negative. So always remember that for elimination, high temperature is good. For elimination, high temperature is favorable. I hope that you got it. How many of you got it, the temperature rule? Tell me in the chat section if you got it. If this is clear, that for elimination, what is the rule? Why high temperature is required? Sahana, welcome. Sausi, kids, do let me know. Everyone, is this point clear to all of you, that for elimination why high temperature is required? Whenever you increase the temperature, it is going to favor elimination reaction. I want to see kids. Okay, one kid, two kids. Those who got it, show me green heart, kid. Why for elimination high temperature is good? Very good, very good. Now let me tell you, kids. Okay, don't worry. See kids, let me tell you, let me show you. Once again, let me tell you, don't worry kids. Those who are unable to understand, don't worry kids. See, if I write it like this, this is reaction CH3, CHBr and CH2H. Wherever this Br is located, this is alpha carbon, this is beta carbon. Now I have added C2H5ONa to this, C2H5ONa. Now who is going to form with whom bond? This will form a bond. This will form a bond with this one. Bromide will eliminate out by taking electron negative. So here we will get positive charge, and this C2H5O negative, this is O negative, that was positive, will take away this proton, so it will form ethyl alcohol. Let me write down. This is forming NABr. This is getting formed as C2H5OH. And this is having negative and positive. They are forming what? Bond. Which bond, kids? See, CH3, CH double bond, CH2. Now, on the reactant side, how many types of molecules we have taken? Two types of molecules we have taken. Right? And on the product side, how many types of products we have got? We have got in total how many types of products? 3 types of products. So you know that the change in entropy is what? change in entropy, you know, change in entropy is S final minus S initial. So final 3, initial 2, 3 minus 2 is coming out positive or not, kids? Now you got it. Delta S is clear. Now let me focus on that reaction is endothermic or exothermic. This is 1 sigma, this is 1 sigma. 2 sigma are breaking and 1 pi bond is getting formed. Which is stronger bond? Sigma are stronger, these two are stronger, that is weak. So energy is required to break the bond, and whenever the bond is getting formed, energy is released. So required is more, released is less. So the process is endothermic. Delta H is positive. Now delta S is positive, delta H is positive, and we know one equation. That equation is known as Gibbs-Helmholtz equation. Gibbs-Helmholtz equation. What is that? That Gibbs-Helmholtz equation says, let me write down on the next page. This Gibbs-Helmholtz equation says that delta G is equal to delta H minus T delta S. These all are of system. This is system, that is system, this is also system, and at constant temperature, Now if I say, kids, if I say you are increasing the temperature of the system, so what is going to happen? That you see this we got positive. Temperature in Kelvin is always positive. Temperature in Kelvin is always positive. So this is in Kelvin positive, and delta S is also positive. So positive and positive magnitude will get positive, and this is negative. So which magnitude should be more? If this is going to be more, then delta G will come positive. If this is going to be more magnitude, then this will come negative. Then what do you want? If this is going to winner, reaction will not take place. If that is going to be winner, then all the reaction is going to take place. We know that if delta G is coming out negative, then only the reaction is going to be spontaneous. Otherwise, reaction is not going to be spontaneous. So to make it negative, we have to make this to be the winner. And who is going to make it winner? Temperature. So high temperature is good for what? Good for elimination. One point is clear, kids. High temperature is good for elimination. Now tell me, everyone got it? Is this point clear to each and everyone, that high temperature, kids? Tell me, kids, is this point clear to all of you? Why high temperature is good for elimination? Do let me know, kids. Do let me know, everyone. Now, let me tell you. So right now, if the same reactant I am going to take, same reactant I have taken CH3 CHBr. Let me write down in this way, this compound in a better way. CH3 CHBr and one more CH3, the same compound is same. The same C2H5ONA, C2H5O negative and Na positive. Now Na plus will take away this bromide negative. It will go, hey, I wanna love you. So it will go with sodium. Now carbon is saying, oh, I'm too feeling positive, but I'm having less electrons. So this C2H5O negative will come and attack on this carbon. Attack. Shy. I'm yours. So O C2H5 and this carbon will say, oh, my OC2H5, I'm yours. Now this has formed NABr. Now just see, kids, Now this is acting as nucleophile, so it has formed ether. I have told you in the starting only it will form ether and salt. Now tell me kids, how many types of reactants were present? 2 types of reactants were present, 2 types. How many types of products have been formed? 2 types. So my dear students, just do let me know this time our change in entropy is 2 minus 2 is approximately 0, because degree of vibrational degree of freedom will be there, so approximately 0. Now see, this carbon belongs to which group? Carbon, silicon, germanium, tin, lead, and halogens belongs to fluorine, chlorine, bromine, iodine. Just see, fluorine, chlorine, bromine, iodine. Second period, third period, fourth period, fifth period. Bromine is 4p, carbon is 2p, bromine is 4p. Bromine is saying, hey carbon, you are very, very small. Carbon is saying, yes, you are so big, I don't want to live with you. So this bond is weak bond. Weak bond has been broken up. But see, carbon is second period and oxygen is also second period. Carbon is saying, hey, oxygen, you are my love. I love you. You are my best friend. So strong bond has been formed. Strong bond has been formed. Weaker bond is broken, stronger bond has been formed. So energy required to break this weak bond is less, and energy released is more. Required less. Exothermic reaction, and exothermic reaction means delta H is negative. Gets exothermic reaction, exothermic delta H is negative. So who is going to decide delta G? Now delta G is equal to delta H minus T delta S. Delta H is negative, this Kelvin positive, and this is negative. Negative and negative will come out to be, oh, it's 0, it's not negative, it's approximately 0. So this will cancel out, this term will cancel out. Only delta H is going to decide. And once the exothermic reaction is there, tell me, low temperature is good for exothermic reaction or high temperature? Lee-Chatelier principle. Do let me know Lee-Chatelier principle. Apply its Lee-Chatelier principle and tell me in the chat section what is good for this reaction. Then 100% the answer will come out. Low temperature is good for substitution. Answer will come out. Low temperature is good for substitution. Low temperature is good for substitution reaction. I hope this point is clear, that low temperature is good for substitution. Everyone, you got it? Do let me know kids in the chat section if you got it, that low temperature is good. Reasons kids, this year the paper will come tough. 100% the paper will be tougher side kids. We have to understand each and everything. If you're not able to understand these things, you won't be able to do anything kids. Are you getting my point, that low temperature is good for this reaction? Now see kids, today I will tell you how to find out any type of reaction. Are you ready? Baba will tell you how to find out any type of reaction. Only in one go. First, let me show you the magic. Today, you will be able to understand. I will teach you which nucleophile is better, which nucleophile is this and that. But just give me 10 minutes. I'm going to show you the magic. Just give me 10 minutes. I will prove that everyone is going to understand how to find out it is SN2, SN1, E2, even without knowledge. Not having knowledge, then also you can find out whether the reaction is SN2, SN1, E1, E2. I want to see the green hearts if you're ready. Just see, only with this single page I will tell you each and everything. Only with this single page, I am going to tell you each and everything. Call your friends, everyone. Everyone, call your friends. Just in 10 minutes, I am going to tell you each and everything, how to find out whether the reaction is SN1, SN2, E1, E2. Without even any knowledge. If you're not having knowledge, if you are having zero knowledge, then also you are going to understand. I will show you kids some magic. I will show you the magic. Today, magic is going to happen. Just see. Are you ready? Everyone ready? Now see. Today magic is going to happen. Today magic is going to happen, kids. Now you will say, yes sir, magic is going to happen. See. Everyone just see. Now just for 10 minutes. For 10 minutes, there is no need of any knowledge. I am going to tell you one story. You have to listen that story. You can solve any question of any exam, whether IIT or NEET. Are you ready? In this story, there is no need of any brain. This is filmy story. Are you ready, everyone? Are you ready? Say, write down, ready, ready, ready. Everyone write down, just ready. Then I'm going to start the story. I'm going to start the story. Write down, everyone write down, ready, ready, ready. I want to see in the chat section. Then I'm going to tell you, kids. Write down, ready, 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 everyone. Kids, fast. Now see. The story begins with that there is one movie and the director is making that movie, and in this movie he has to take 3 types of heroines. How many types of heroines? 3 types. 3 types of heroines. First heroine is 1 degree. This heroine is having only 1 degree. MBBS degree, only MBBS degree, 1 degree. This heroine is having 1 degree, this heroine is having 1 degree. These 3 heroines are having only 1 degree. 1 degree. How to find out the degrees? How to find out the degrees? Just see. Carbon attached with no other carbon, or carbon which is having X that is attached with one more carbon. Can you find out the degree of heroine? The carbon which is having halogen, that carbon is either attached with one more carbon, then 1 degree, or no other carbon, then it is 1 degree, and X is equal to either chloride, bromide, or iodide. Now the second type of heroine is having 2 degrees. She is MBBS as well as having MD, 2 degrees. Now how to find out the degree of 2 degree heroine? Just see, the carbon to which X is attached, that is further attached with 2 more carbons. Will you be able to find out the degrees of the heroine? If carbon is attached with halogen, that carbon is further attached with 1 more carbon, 1 degree. No other carbon, 1 degree. 2 more carbons, 2 degree, and the carbon to which this halogen X is attached, if it is attached with 3 more carbons, then 3 degree. First of all, do let me know. 1 degree heroine, 2 degree heroine, and 3 degree heroine. In the movie, 1 degree heroine is just having MBBS degree. This heroine is having just 1 degree, and 2 degree heroine is having 2 degrees, MBBS and MD, and 3 degree heroine is having MBBS, MD, and she is very, very beautiful. Very, very beautiful. Now kids, this much is clear. Is this much clear? 1 degree. These first three are 1 degree, this is 2 degree, and this is 3 degree. Will you be able to find out? Will you be able to trace? Will you be able to identify 1 degree, 2 degree, and 3 degrees? Right? If this much is clear, then I'm going to move towards types of hero. This is SN2 hero, E2 hero. These two heroes says, I will do marriage. I will choose heroines and I will do marriage, but I will do marriage without engagement, single step reaction, very fast. And they are saying, oh, first I will talk to them, then I will make friendship, then I will do engagement, and then marriage. Slow process, slow, more than one step, fast. Till now this much is clear, the part of the movie. Now see which hero is liking which heroine. Just see. Right now I am telling you the story, but later on I will tell you the reasons. I will give you the reason, each and everything I will explain. But see, right now I am just telling you the story, so no reasons, no science, not at all. Right now see the liking of hero. This hero SN2 likes 1 degree heroine. SN2 likes whom, kids? Do let me know. SN2 likes whom? SN2 likes whom? Tell me SN2 likes whom, kids? SN2 likes, liking of SN2 is for this 1 degree, this 1 degree, this 1 degree, and 1 degree heroine also likes this hero. 1 degree heroine also likes this hero SN2. Right? Remember these likings. Now, rest of all other heroes, they like this heroine, 3 degree, the most beautiful and having degrees also. And even this heroine is liking all these 3 heroes. Why? That I will tell you in science. Right now it is story only, kids. So no, nothing about, but you will do all the questions. Till now it is clear. SN2 likes 1 degree heroine, and rest of heroes, they are liking 3 degree heroine, 3 degree, and 3 degree is liking 3 heroes, and this 1 degree is liking only SN2. Now what's about this 2 degree heroine? But I will tell you about 2 degree heroine. First I want to say, till now everything is clear. That is gone to your brain. First of all, show me green hearts if yes, and then after that you will be able to solve all the questions. I will show you, kids. I will give you the reasons also, kids. But first of all, tell me, till now it's okay? Till now everyone is able to understand this much, kids? Show me green hearts if you are able to understand the story till now. Madhumita, yes. Arya, Thambi, everyone. Kids, once you are going to enjoy the questions, then you will say yes. Oh my God, sir, you are really brilliant. You will say like this. You will start talking like this. Okay, now see. What's about 2 degree heroine? No one is talking about 2 degree heroine. So see, what's about 2 degree heroine? See, kids. He is saying that I have feelings for 2 degree heroine, but my feelings are broken feelings. This is also saying my feelings are broken for this. This is also saying my feelings are broken feelings for this, and this is also saying my broken feelings. Everyone is liking, but with broken feelings. So heroine is also saying I like all 4, but broken feelings. I like all four, but broken feelings. I like all four, but broken feelings. Now, once again, let me tell you, SN2 loves only 1 degree heroines. These three loves 3 degree heroine, and all their feelings for 2 degree is less broken feelings. So if I talk about heroine, 1 degree heroine loves SN2, 3 degree heroine loves all these three, and 2 degree heroine loves all four, but not too much broken feelings. But director said, hey, in this movie, no heroine can have more than 2 types of marriages. This is movie, kids. It's not in real life. It's nothing to do with the real life. This is movie. No heroine can do more than 2 marriages. Maximum marriages are 2. Now who will decide? Because this heroine is liking all 4. This heroine is liking these 3. Now who will decide? Pappaji will decide. This is Pappaji. Pappaji means Dada. Dada will decide. When the heroine is not able to decide with whom, which 2 she has to, form a bond, then the Pappaji will come into role. Father will come into role. Till now it's clear. Now, this father is strong father. How to find out strong father? I will teach you, but right now, remember, RO negative. Total negative charge is there, then it is a strong base, strong nucleophile. How will you find out? Either RONA written or written ROK, either RONA written, ROK written. Why I am saying this is ionic bond, so it is RO negative only. So RONA written like C2H5ONA written, or it's written like C2H5OK. All they are having negative charge, because in between this C2H5O negative and Na positive there is being ionic bond. So you have to consider it to be RO negative. All these are strong. Now this is strong, and a strong Pappaji father says, I like those heroes who can make this marriage possible in single step. So this Pappaji says, these are of my choice. I want these because these are doing this reaction in single step. These are stronger ones. So this Pappaji is saying either this or this. Got it? Strong father, strong hero. These heroes are saying, I want to marry in single step. Pappaji, this father, is also saying, yes, even I'm strong. I want to make this marriage possible in single step. But this Pappaji, HOH, ROH, poor weak, he is saying, oh, first I will search what hero is doing, whether he is having job or he is not having job, what's the degree of the hero, number of blah blah, number of things. I will search for that. How much land he is having, what type of car he is having. Then I will decide. These heroes are saying, yeah, same feelings. Even we want time. They need time. So this father is loving these heroes to have marriage of their what? Daughter, his daughter, right? Till now the story is clear. First of all, tell me, till now the story is clear, kids? Kids, till now tell me the story is clear or not. Then I will show you the magic. Then I will show you the magic, kids. Magic is going to begin. Do let me know. Do let me know, kids. I want to see green signal if till now the story is clear, kids. Okay. So, it is gone to your hippocampus. If it is gone to your hippocampus, which hero is loving which heroine? Which father says which? Okay. Now see, kids. Now see. Let me show you the questions of previous exam questions. See, if you are ready, Once tell me kids, everyone, the story is going to your brain, then only I am going to start with the questions, otherwise not. Till now the story is clear? Yes. Now see, what type of heroine it is? Write down in the chat section how many degree heroine it is. This heroine is having how many degrees? Kids, if you have got the story, then only it is going to help you. What is the degree of this heroine? I want to see in the chat section. If you are not able to write down, then leave it. You won't be able to understand. Sahana, yes. Only one Sahana has written that it is having 2 degree. 2 degree. Mahalakshmi has written, unknown user, yes, 2 degree. The degree of heroine is 2 degree. Yes. Why it is being 2 degree? Just see. The chlorine attached to the carbon is further attached with 2 more carbons. 2 more carbons. So this is 2 degree. 2 degree heroine was loving whom? 2 degree heroine was loving whom? Do let me know. The love of 2 degree heroine was, let me show you. 2 degree heroine was loving. 2 degree heroine was having feelings for all 4. Feelings for all 4. Now that means she is unable to decide with which hero she has to marry. She was having feelings for all the 4 heroes. Broken feelings, right? Broken feelings for all 4. Now who will decide with whom she has to marry? Who will decide? Father will decide. Now see the father. Who is the father? R-O-N-A. Just see, the father is strong. R-O-N-A. Father is strong or weak? Father is strong or weak? Father is strong. Father is strong. Strong. Nucleophile oblique base. Strong nucleophile oblique base. Now father says to whom she has to marry. This strong father loves both of these. So the marriage will take place with whom? With whom? Tell me the answer. This marriage will take place with whom? Definitely your answer should be SN2 E2 both. E2 both. SN2 E2 both. You got it? Got it, kids? This answer, how many of you got this answer, kids? Kids, I'm really telling you these many things. No one will teach you like this, kids. Are you getting my point, kids, or not? Do let me know, kids. Are you able to understand or not? It's done and dusted. It's being done or dusted or not, kids? Thank you, Sana. Thank you, Mahalakshmi. Riya Desai. Kushiga. Wow, Kushiga. Tell me, kids, you got it? You are really liking this way or not? Are you really liking it? Now let me show you another one. Now kids, those who are not able to understand, let me tell you another one. But remember that here elimination will be major. This is 40%, that is 60%. So this you have to cram, that elimination is major. Elimination is major. Now those who are unable to understand, let me give you another example. See, what is the degree of this heroine? The carbon is further attached with 2 more carbons, so 2 degrees. Secondary alkyl halide, loves all. Now father is poor. Father is poor. How to know poor? Just see, father is poor. R-O-H-H-O-H, father is poor, and this type of father loves SN1 E1. So girl is loving all 4, What father is saying, these two are okay. Now what type of reaction will take place? Do let me know in the chat section what type of reaction will take place. If you are really able to understand, I want to see what type of reaction. Definitely I want to see in the chat section SN1 and E1. Very good, kids. SN1, E1. Now, till now, what information you got? Till now, what information you got? Whether the father is strong or the father is poor, 2-degree alkyl halide always undergoes substitution as well as elimination. See, with strong nucleophile, substitution as well as elimination. Substitution will produce what? Substitution will produce ether. Elimination will produce alkene. That means substitution and elimination taking place simultaneously. Simultaneous NSR as well as elimination. Parallel reaction, kids. Parallel reaction is taking place. Parallel reaction, got it, everyone? Parallel reaction is taking place. Now, if father is poor, then also substitution and elimination. Substitution will produce ether. Elimination will produce alkene. That means substitution and elimination taking place simultaneously. Simultaneous substitution, that is ether, and alkene, that is elimination, kids. Now see another reaction. What is the degree? Once again, 2-degree ethyl alcohol. So I can say ether plus alkene will be the product. Ether plus alkene will be the product. Ether will get produced through SN1 mechanism. Alkene will get produced through E1 mechanism. So multi-step, yes, multi-step reaction, right? This is clear. Now see another one. If I say this is, what is the degree of this heroine? Do let me know in the chat section. What is the degree? This halide attached to the carbon, and this carbon is further attached. 1, 2, 3. 3-degree heroine it is. 3-degree heroine is liking SN1, E1, E2. What doesn't like SN2? She says, I don't like SN2. What father is strong? Father is being a strong base as well as nucleophile. Now father is saying, I like, see, strong father loves whom? Strong father loves whom? Strong father. Now see, the heroine is liking, this heroine is liking whom? This heroine is 3-degree, and 3-degree likes, 3-degree likes E2, SN2, E1. But father is saying, I am being strong. I don't like these two. Strong father loves only E2. So these two will not take place. Now see, kids, what should be the product? Means what type of reaction will undergo? Tell me in the chat section what type of answer you are going to get. If really you are able to understand, tell me what type of reaction. Nitishan is saying E2, Namita is saying SN2, E2, Arya only E2. Very good, only E2, kids, only E2. And that's why, kids, if you remember, Williamson said, if you want to prepare ether, never take 3-degree alkyl halide. If you are really dropper dreamer, then Williamson synthesis says, if you want to prepare ether, never ever take 3 degree alkyl halide. Do you remember? So only elimination, whether temperature is given or not, doesn't matter, kids. I've told you, if temperature is given, then temperature will increase the yield, will favor more elimination, but here only elimination is taking place. If I talk about this reaction, see, if I talk about this reaction, and here if I am going to increase the temperature, right now 60-40 ratio is there. If I increase the temperature, then 70-30 ratio. If I keep on increasing the temperature, 80-20, 90-10, when there are more possibilities possible that both parallel reactions are going to take place, SN2 and E2, then lowering temperature, increasing temperature, that is going to affect, but only if one type of reaction is taking place, that is only elimination, then that no temperature is mentioned, then also elimination is taking place. This is the magic. Other kids won't be able to understand. They will say, oh my God, temperature is not mentioned, then how is it possible that E2 reaction? But kids, even without temperature mentioned, if you are able to find out that bulkier group, this is bulkier, I will tell you the science behind it. Now, is it clear? Now see kids, another reaction in front of you. If I give you this one, once again this is 3 degree, but here it is weak base, Papaji is weak. Now what type of reaction? Do let me know. This says yes, to whom it is liking? It is liking SN1. She is liking SN1, E1 and E2. But Papaji is saying I am weak. I am liking only SN1, E1. This is saying multi-step. I am saying multi-step, 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 common. Multi-step, multi-step, common. Now multi-step, common. So type of mechanism, SN1, E1, both ether and alkene, ether and alkene. I hope this is clear to each and everyone till now. It's clear. Do let me know, kids. Till now it is clear to each and everyone. Everyone is able to understand. Wow, kids. Kids, are you getting diamond or not? Really you are getting diamond or not? Kids, do let me know first of all. Everyone is getting diamond teaching, diamond content. Do let me know, kids. Kids, if you are really enjoying, always show green hearts, fire, that yes, you are getting something great. Very good, kids. Very good. Now, see this one. What is the degree of this heroine? Just see the degree of this heroine. The chlorine attached to the carbon and carbon further attached with one carbon, 1 degree. 1 degree is saying I love only SN2, and father is saying I am strong. Yes, okay. So this is saying single step reaction, and father also says single step reaction. Both are ready for single step. So single step, that means only SN2, only SN2, and that's why this is the favorite of Williamson synthesis. Williamson synthesis says that if you want to get good yield of ether, Williamson synthesis says what? If you want to have good yield of ether, always take 1 degree alkyl halide, then 1 degree alkyl halide will give you best yield of ether, best yield of ether, kids. Best yield of ether you will get. Everyone, is it clear? Is it clear? Now see, kids. Next question. Tell me what's the answer. Let's see who is going to give the correct answer. I'm waiting for the correct answer, kids. Let's see who is going to give the correct answer. Do let me know, kids. Let's check it out. Who is going to get the correct answer? Do let me know, kids. Best yield of ether. Who is going to get the best yield of ether? Which option? Second. Maximum people are going for second. Okay. Let's check it out. What should be the correct answer? Let me check it out, kids. Let me check it out. Just wait. Let me check it out, kids. Let me check it out. See, where is the reactant? This is having X, carbon halogen bond. This is the reactant. This is a reactant. This is the reagent. And the reactant is 3 degree. 3 degree, and this is being a strong nucleophile base. So only E2. E2 means alkene. We will get only alkene. Now, see, kids, this one is carbon halogen, 1 degree alkyl halide, strong nucleophile, only E2, SN2 only ether, the best yield of ether. Now, this is the correct answer. This is 2 degree alkyl halide, strong base nucleophile, oblique base. So definitely it is going to show SN2 and measure of E2 60% alkene, 40% ether. Now this is being 3 degree and this is being a strong base. Now this will do E2 only alkene. E2 only means only alkene, no ether. So definitely your answer is going to be second one. I hope this is clear to each and everyone. This is being clear to each and everyone. Now see, kids, now let me start from the beginning. I have told you the story, but now I am going to give you the science behind it. Are you ready, kids? Now, let me tell you the factors affecting nucleophilicity. I hope that everyone is ready for the factors affecting nucleophilicity. Now, see, factors affecting nucleophilicity. Who is better nucleophile? How to find it out? Remember that first factor number one. Remember that negatively charged entity is a better nucleophile, than its own neutral form. What is the meaning of this? Neutral form. The meaning of this is, kids, remember that if I write down OH negative, this OH negative is a better nucleophile than water. What do you mean by this? This water, remember that water is not OH negative. If you take many water molecules, then only few water molecules are going to break into H plus and OH negative. Now, what is OH negative? OH negative is having complete negative charge. This OH negative is having complete negative charge. Remember, my dear students, complete negative charge. But if I talk about water, water is having partial negative charge. Now, my dear students, partial negative charge and complete negative charge. Whose charge is more? This charge is more. More charge, more need of H plus or carbon. So nucleophilicity is higher. I hope that you got it. That negatively charged entities, they will always have more nucleophilicity than neutral entities. So how they will give question? My dear students, this they can give you OH negative, or they can simply give you like NaOH. if they are giving you NaOH, then consider it to be OH negative only. Why? This is the reagent, this is being the reagent, but its nucleophile will be OH negative, because once you are going to add it in some solution, it will break because there is ionic bond Na positive, OH negative. This is the nucleophilic part, and this is complete negative charge, NaOH, KOH, whatever they are giving, this is being strong. So give one more example. Okay, let me give you one more example. If I write down NH2 negative is a better nucleophile than ammonia, so they can give you NH2 negative like NaNH2 or KNH2. They can give you like this. So it is a better nucleophile than the one who is having complete negative charge. Now you must be thinking, sir, what is the difference between reagent and nucleophile? That is one more question, burning question, that what's the difference between nucleophile and reagent? Let me explain. Let me explain, kids. What is the difference? What is the difference, kids? See, if I write down that, just see the analogy. I am going to give you the analogy. Let me give you the analogy for this, kids. If I tell you that from the market you are getting two types of fruits. Suppose if I say that from the market you bought banana. Banana, this is one type of fruit, and you got grapes. This is another type of fruit, grapes. Okay. Now once you start eating, how will you eat banana? First you are going to remove the cover. Remove the cover. Then whatever the part you are getting, this you will eat. This you will eat. This is the eatable part. Am I right, kids? That means you bought banana from the market, you remove the cover, and then you have eaten this part. But about grapes, are you going to remove any part? No, you will wash it, and then you will eat grapes like this only. Now, kids, the thing which you bought from the market and the thing which you are eating, this you got from the market, the first part, the form in which the things are available in the market, availability in the market, and the thing which is in the form you are going to eat, the attacking part, eating part, or you can say attacking part. These two things are, see what is the difference. The thing which is available in the market, that is a reagent. Remember that. The thing which is available in the market, that is a reagent. And the part which is going to attack, that is base or nucleophile. Now let me explain this thing with respect to chemistry. So if I say that you are having C2H5OH, this is the reagent as well as it is the attacking part. Why, kids? Why? Just see, in between O and H there is covalent bond. Remember that covalent bond will not allow to break it. It will remain like this. This is the covalent bond. Then it has to attack in this form only, the form which you bought it from the market. It has to attack, so it is having partial negative only, partial negative. Now banana part. Now let me give you, kids, banana part 1. You bought from the market C2H5ONA. Let me use another color so that you should not get confused. Let me use another color so that you are not going to get confused. So you bought C2H5ONA. Now what is the type of bond in between O and Na? This is ionic bond. Now the ionic bond, this is the reagent part. This is known as a reagent. When you add inside any solvent, it will break, and the attacking part is only C2H5O negative, so it is having complete negative charge. This is a better nucleophile than this one. Are you able to understand, kids? If anywhere it is given like this C2H5O Na, then this is going to be the better nucleophile than C2H5OH. This is the reagent, that is also the reagent, but if I talk about its nucleophilic part, then its nucleophilic part is C2H5O negative. This is the nucleophile oblique base, but if I talk about its nucleophile and basic part, then still it is remaining C2H5OH only in nucleophile or base. Then which one is having more charge? This one is having more charge, so this is a better nucleophile. You got it, kids? Till now, just to let me know, kids. I'm telling you the depth of the chemistry. I'm not teaching like in this way or that way, kids. Baba is giving you the quality content. You do let me know that everyone is able to understand or not. It's half moon, not banana. Oh my god, it's looking half moon. Oh my god, kids, everyone is able to understand or not? Do let me know. Do let me know. Is everyone is able to understand? Got it or not? Teju, Deepika, what you want to ask? Deepika, what's your query? Deepika, what's your query? Do let me know. Do let me know. Thank you, Manoj Jain. Deepika, what's your query? Do let me know. Now, first factor is clear. The one who is having negative charge is a better nucleophile than the one who is neutral one. Okay. Okay. Now see kids. Now see the second factor. If I come to the second factor, factor number 2 for nucleophilicity, if I come to the second factor, then the second factor is, see, factor number 2. Remember that if the size of, if you have to follow the sequence, if you want to get good marks, follow the sequence. If the size of atom having negative charge is same, then nucleophilicity is directly proportional to basicity. Directly proportional to basicity. Remember that. Basicity actually refers to acids, but nowadays basicity means basic strength. Nowadays basicity is used for basic strength, and basic strength you know very well. So let me give you some examples so that it should be more clear. Now see kids, if I write down CH3O negative, OH negative. Now see kids, in this case this methyl is donating electron through plus I, so the charge is getting increased. More electron density, more electron richness, more electron rich, it is becoming more electron rich. So nucleophilicity is also increasing, basic strength is also increasing, everything is increasing. So because of plus I. Now let me give you another example, some more examples so that you can easily understand. Let me show you. Suppose if I write down CH3 CH2O negative, then it's a better nucleophile than CH2 double bond CHO negative. Now the question arises, why it's being a better nucleophile? Why? What's the reason? See kids, if I tell you that here it can't do resonance, no resonance means the negative charge is, no resonance means the negative charge is localized. So it is complete negative charge, one negative charge, but you can see just the adjacent carbon atom, it is being sp2 hybridized. So it will do resonance, and it is doing resonance. That means it is delocalized. Negative charge is involved in resonance. Negative charge is involved in resonance, So my dear friends, if I talk about its resonating structure will be like this. Sometime negative charge over there, some other time negative charge will come to this place. That means these are the two resonating structures. They are doing resonance like this. So what should be the actual structure? That actual structure will be in between these two. So the actual structure will look like this, that CH2, CHO, partial negative over there. So the charge has been divided. So 1 by 2, you know the pain. If you divide the pain will become, that is going to decrease. It is having total 1 negative charge and it is having half charge. Who is having more charge? This one is having more charge and this one is having less charge. So of course, why not? That is going to meet with positive charge immediately. Its charge is more, nucleophilicity is more, basic strength is also more. I hope kids, everyone is able to understand that the nucleophilicity and basic strength is directly proportional if the size of the atoms are same. The one who is bearing this negative charge is same. I hope everyone got it, kids. Now let me tell you something, my dear friend. Let me give you one order. So then I am going to move ahead. Remember that if I write down like this, CH3 negative, NH2 negative, OH negative, F negative. So if the size of atom bearing the negative charge is same, then the negative charge is more stable. Remember this point, kids. Negative charge, if size is same, then negative charge is more stable. The negative charge is more stable on more electronegative atom. Now that means, gets what? If size is same, then negative charge is more stable on more electronegative atom. Then you remember the electronegativity, that fluorine's electronegativity is 4, oxygen is 3.5, nitrogen is 3, carbon is 2.5. That means negative charge is more stable over there. So negative charge is least stable at this place. So the nucleophilicity order will be like this, and the same order will be for basic strength also. So this is the best nucleophile as well as best base. I hope that everyone is able to understand. So this, then this, then this. But there is one very, very special base that you have not to forget about it. Just see, always remember this base. This is too much sterically hindered. Like if you have seen the movie like Spider-Man, there was one Spider-Man, sleek, slim and trim. There was octopus having tentacles. When Dr. Octopus was moving, he was destroying all the buildings because he can't go like this. Suppose if somebody is there, like lion is there outside of your house and one elephant is there. So you are inside the room. With whom you are going to get scared of more? Definitely with lion, because lion will get entry. He will come through that door, but elephant can't come. It's like bulky Hulk. So the one who is bulky can't get entry inside the room. So my dear students, this is too much bulky. Remember that too much bulky means what it is going to do. Too much bulky. Too much bulky, kids. So definitely it is, although it is being very, very strong base, although it is being very, very strong base, very, very strong base, but because of steric hindrance, but kids, remember that, but because of too much steric hindrance, can't behave as nucleophile. I'm not saying it is a weak nucleophile or poor, but he is not able to reach up to the carbon, so can't behave as nucleophile with 99% reactants. With methyl halide, there is only one methyl halide with whom it will act as a strong nucleophile. It will act as strong nucleophile with methyl halide. Methyl halide is least sterically hindered, so this will act as with methyl halide. Its name is potassium tertiary butoxide. Potassium tertiary butoxide. Now where is potassium? Behave as strong nucleophile. Only with this one will behave as strong nucleophile. Now this one is very, very important in how many forms they are going to give you this base. Just remember that they can give you like this. They can write it like this also. See, Me3COK. They can give you like this, or they can give you like this, TBUOK. Now, what is the meaning of TBUOK? T, tertiary bu, tertiary butoxide, potassium tertiary butoxide, potassium tertiary butoxide. They will give you like this. Now my dear students, just see, they can give you like this also, TBUONA, sodium tertiary butoxide. And anyways they can give you. So remember of this base, this is too much sterically hindered. Kids, do let me know till now it's okay. Do let me know in the chat section. Let me have a sip of water. Till now I will see that everyone is able to understand or not, kids. Baba's quality content. Everyone, I hope that everyone just to let me know. Do let me know, kids. Till now I hope that it's clear, so that I can move ahead, my dear friends. Do let me know. Everyone, perfect. Arya, very good. Soumya, Cyril, Ayara, Sacha, Deepika, wow, great. Now let me move ahead. These two factors I have told you. Now the another factor, the effect of solvent on the nucleophilicity. See, kids, solvent effect. Let me tell you the solvent effect on nucleophilicity. First, solvent effect on nucleophilicity. Baba is going to tell you solvent effect on nucleophilicity. Are you ready, kids? Are you ready, everyone? Now see, to understand the solvent effect on nucleophilicity, first we have to understand in gaseous state. In gaseous state, what is the size of atom? What is the size of atom in gaseous state? See, fluoride, bigger than fluoride is chloride, then bromide, and then the iodide is the largest one. Iodide is the largest one. but this order is in gaseous state as well as in molten state. Same order is in molten state also, kids. But remember that once they go inside the solvent, their size can change. It's not definite that their size is going to get changed, may change, right? So what is their size in that particular solvent? That solvent will decide the size, and whatever is the size in that particular solvent, that is going to decide what is their nucleophilicity. And nucleophilicity has to do with the speed, nothing to do with the strength of the bond. Remember that nucleophilicity has nothing to do with the strength of bond. Remember that one point, kids. What I'm going to tell you, nucleophilicity means the speed or the rate. It's a chemical kinetics term, deals with the chemical kinetics. Remember that. That is what? That is chemical kinetics. So it is deals with the speed or the rate by which any entity is going to form bond with positively charged carbon, positively charged or partially positively charged. It has nothing to do with the strength of bond. Nothing to do with, it is saying, hey, strength, that's your business, that's none of my business. Nothing to do with bond strength, nothing to do with bond strength. Nothing to do with bond strength, only the speed. Why? What speed? A nucleophile. So nucleophilicity means the speed, whereas basic strength, that refers to the chemical equilibrium, kids. Now see, remember these following factors, then only you can understand. Nucleophilicity refers to the size, that means inversely proportional to the size of what? Size of solvated ion. Size of solvated ion. Kids, if you are not able to understand this thing, you won't be able to understand anything. Remember that, kids. Remember that. You should know this thing. Size of solvated ion means size after solvation. The one whose solvated size is least. Remember that. If the solvated size is least, remember my words, kids. If solvated size of ion is least, then that is going to be the best nucleophile. I hope you got it. Solvated size. What I said, solvated side, not its gaseous size, its solvated size. And let me tell you the second point. How the solvent is going to affect. Are you ready for that? Just see kids. If I talk about polar protic solvent, remember that once they are going inside the water, remember that water is like mother. Water loves smaller ions maximum, smaller ions. See, the fluoride which was smallest in air, and the iodide which was largest in the air, once they go inside the water, hydrogen bonding will take place and the water will come like this. Polarity is there, it will start forming bond with this fluoride like this, gets it is true intermolecular hydrogen bonding. One layer, the first layer will get formed just like celebrity. These people are taking autograph, and one more layer will be there, kids, of water. One more layer. Maximum solvation due to hydrogen bonding, intermolecular. So its size will be now this much of radii. Earlier its radii was only this much. Now the radii will go up to this. This is all because of maximum solvation. Now here solvent, if I am taken water, polar protic solvent, I will tell you the examples of polar protic solvent. Maximum solvation, maximum hydration in case of water, maximum size. Its size is being maximum size. Now kids, iodide, so big, polar protic solvent are not loving water. Water is an example of polar protic solvent. Now see, polar protic solvent, iodide, what I will say, hey, from where you have come, I'm not going to love you. Only few water molecules will come and start forming hydrogen bonding. Now its size after solvation is this one. This is more bigger than iodide. This is smaller. Now what do you think? Who will run fast? Smaller due to less solvation. So this is smaller in water. The one who was biggest in the air, water has converted into smallest, and the smallest got converted into biggest. The polar protic solvent, they will turn out bigger to be smaller and smaller to be bigger, and that's why in polar protic solvent, what is going to happen, kids? What is going to happen? Do let me know what is going to happen in polar protic solvent. Definitely in polar protic solvent, in PPS, the nucleophilicity order will be iodide aqueous is better than, or any solvent. I have taken aqueous, any solvent you can take, bromide aqueous, then chloride aqueous, and then fluoride aqueous. This will be the order. Now my dear students, I'm not saying only water you can take. Examples of polar protic solvent can be, examples are water, alcohol, or you can take carboxylic acid. All these are the examples of polar protic solvent. And remember one point, that polar protic solvents will solvate both the cationic and anionic part of reagent. This is the note. Remember that. What is the note, kids? Polar protic solvent. The polar protic means, polar protic solvent means what? Which are polar as well as can donate proton. Polar and can donate proton. So these type of solvents will solvate both cationic as well as anionic part of the reagent. How they will solve it? If you want to understand in detail, kids, let me tell you kids, let me tell you. Suppose this is NaCl, there is ionic bond, that means ionic bond, the water will surround it from all the sides. First it will break this bond, that means hydration energy greater than lattice energy. First the electrostatic force of attraction, that is ionic bond, will break. So first it will do the breaking part, it is going to break and then it will solvate. First the water will break it in two parts, that is Na plus has been broken with chloride. Now what water is going to do? First it has broken, and broken is known as hydrolysis. It has done hydrolysis. Lysis means breaking of bond. Lysis word means breaking. And then it will surround it from all the sides. It will surround it from all the sides. This is known as hydration. Hydration. This is known as hydration. I hope you got it, kids. So whenever anyone is asking what is our order of nucleophilicity, remember that even if the medium is not mentioned, then also you have to say, remember that one point, remember this one point, even if the medium is not mentioned, kids, what I am telling you, even if the medium is not mentioned, medium is not mentioned, consider it to be aqueous. Consider it to be aqueous. It to be aqueous. And remember that the nucleophilicity order will be iodide is the best, then bromide, then chloride, and last fluoride. This will be the nucleophilicity order. And this is reverse of, here it is reverse of what? Basic strength. The basic strength order is just opposite to it. The basic strength order is that. That is the basic strength order. Now kids, I have told you if the size is different, the nucleophilicity and basic strength, they are not directly proportional, they will be inversely. Now let me check it out whether you are okay or you got bored, kids. Do let me know. Are you okay? Are you able to understand, kids? Kids, do let me know if everyone is able to understand. Do let me know, kids. I hope that everyone is able to understand, kids. Right now, kids, I can't give you break. I will give you one break. First break at 9. I will give you one break at 9, kids. Right now, I can't. Oh, it's 9. Then 9:30. 9:30. I will give you first break at 9:30, kids. Okay, kids. Please, humble request. All my dear students, at 9:30 I will give you first break. Let me complete till that time, kids. Kids, Baba never see how many viewers are there, how many likes are there. Baba is always considering about what? Only one thing. Yeah, that 9:30 I will give. Kids, I will give you at 9:30, please. Kids, till that time let me teach. Yeah, thank you. Thank you. Don't ask for session duration, kids. I have to complete it. I have to tell you each and everything. Baba is going to tell you, teach you each and everything now. The second solvent is known as polar aprotic solvent. Polar aprotic solvent. Now see, kids, what is the meaning of polar aprotic solvent first, and what they will do. Remember one point: polar solvents which are polar but can't donate proton, can't donate protons. Now what type of examples we are having for these solvents? Remember that dry ether, crown ether. Now you will ask, what do you mean by crown ether? Any compound polymer, the polymer having repeating unit like this. O, CH2, CH2, 1 O and 2 CH2s, and at least this N should be equal to or greater than 4. Now see how the crown ethers will look like. This type will go like this, and one Taj, that like this. Are you getting my point, everyone? Crown ether, dry ether, crown ether. Now DMSO, DMF, DMA, HAMFA, etc., HMPA. Now you will ask, what are these, kids? Definitely your question will be, what is this, sir? Please explain their structures. So don't worry, kids, I will explain. Baba is here, no fear, right? So see, if I write down DMSO, just see, DMSO. What do you mean by DMSO? Dimethyl sulfoxide, dimethyl sulfoxide. How it will look like? Dimethyl sulfoxide, S double bond O, two methyls, dimethyl sulfoxide. Now kids, before I tell you anything, first of all let me tell you, kids, the most important thing. Before I'm going to give you any break or anything, the most important thing, let me tell you, kids, everyone, this is the most important thing, and you have to share it to each and everyone, kids. This is the team Avengers. You know your Ambika ma'am, Wasim sir, Yavo sir, and this is your HSP sir, team Avengers. Now kids, Phoenix Masters batch, NEET 2.025 batch by this team, NEET Avengers, now at just rupees 4,999. Use my code. Use code. What is the name of this code? HSP10. Let me tell you once again in bold, HSP10, to get mentorship and the huge discount. Use this code. Now kids, just for 4,999 only. Now enroll now. And next, after this, let me tell you, my dear students, get ready for NEET UG 2025-26 with Unacademy All India Test Series, kids. Here are the prices. You can see clearly These are available at all India test series for Nexus batch. Nexus means class 12th. Phoenix means droppers, dreamers, and Nimbus means for class 11th. See, the price is equal, gets easily you can get enrolled. Now, once again, your team, the same team is over here. HSP, Yavo, Vaseem sir, Yavo sir, Vaseem sir, Ambika ma'am. And see this Nimbus Pro preloaded means, my dear students, this Nimbus batch means what? Nimbus means class 11th, you can say nurture batch or class 11th batch, NEET 2026 batch by the same team. You see the lectures, and now once again I would like to say it is available. This is best thing, kids. You see, just for 5,000 rupees what you are going to get? Nothing, kids. Offline fees is 2 lakhs, more than 2 lakhs for 1 year. Now you have to apply code, kids. What is the code? HSP10 to get this benefit along with the mentorship. Live now. Now, my dear friends, remember that Sachin, Neha, Unacademy, National Scholarship and Aptitude, UNCET, you know very well. The Mondays, Saturday 4 p.m. to 6 p.m. Sundays timing is 10 a.m. to 10 p.m. So you can register now. Everyone, kids, you got it? Got it. The information. This was very, very important, and this is your Baba HSP. Let me tell you a little bit about myself. That 20 plus year written, otherwise 26 years, it's an old one. Now I did my MTech in 2004. Before that MSc, 99 gold medalist, GRF GATE, and teaching experience 26 plus years with all ranks 1 to 10 kids with mass selection. Now let me start. Let me come back. I've given you each and everything. The whole information has been provided, kids, to you. So get benefited. Now see, kids, all these things I taught. Now I'm going to deal with polar aprotic solvent. I was telling you polar aprotic solvents effect. Polar aprotic solvent. So I was over here, dimethyl sulfoxide. Dimethyl sulfoxide. After this dimethyl sulfoxide, let me tell you DMA. What is this DMA? DMA means dimethyl acetamide. What's that? Dimethyl acetamide. Dimethyl acetamide. CH3 CONH2. This is acetamide. If in place of 2 hydrogens, if I put their methyl, then it will become dimethyl acetamide. In the acetamide, I added 2 methyl dimethyl acetamide. Now, DMF. What is that DMF? Same. Dimethyl formamide. Dimethyl formamide. Formamide. What is formamide? HCONH2. Now HC double bond O NH2 is formamide. What I'm supposed to do? Just in place of hydrogen, add methyl. Dimethyl formamide. Now what is HAMFA? HAMFA is hexamethyl phosphoramide, hexamethyl phosphoramide. What is this hexamethyl phosphoramide, sir? Okay, let me draw. P double bond O N CH3 N CH3 Hey, CH3. I can write Me in place of CH3. Me means methyl, hexamethyl phosphoramide. All these solvent Baba has written. Now, kids, let me tell you very, very peculiar thing. Peculiar means amazing thing, means anomalous thing about polar aprotic solvent. Let me tell you. What's that, kids? What's that, sir? What's that? Let me tell you, kids, let me write down. Polar aprotic solvent mainly solvates the cationic part only, mainly solvates cationic part of the reagent only, cationic part of reagent only, cationic part of reagent only, cationic part of reagent only. What do you mean, sir? Arey, I mean anionic part remains, comparatively free. Oh my God, remains comparatively free. What do you mean by this, sir? That means it is not going to capture the anionic part. That means the size of anion is not going to get changed. Oh my God, yes. This means the size of anion, will not get changed, Okay. So the anionic size will remain as like gaseous. Yes. The anionic size is almost similar to gaseous size. Okay. So in the gas, who was smaller? Fluoride was smallest. So here fluoride will remain smallest. So who is going to be the best nucleophile? Fluoride is smallest. It will remain like this. Chloride being bigger, bromide even more bigger, and iodide was the biggest one. So the nucleophilicity order got reversed. In PPS, iodide was the best nucleophile, but here this is the best nucleophile, the best nucleophile, and this is the poorest nucleophile. Now, my dear students, question arises: why this solvent has not solvated the anionic part? That is $1,000,000 question, and Baba will explain this. Why? The question arises, why? Now see, kids, if I draw dimethyl sulfoxide, then the dimethyl sulfoxide is like this: partial negative, partial positive, and methyl group like this, methyl group like this. Now you see, if I keep NAF, if I put NAI, now see, kids, oxygen will capture this sodium. It will say, oh, I love you. This oxygen will capture this sodium. Oh, I love you. But see, this is too much sterically hindered. The positive charge of solvent, positive charge of PAS is too much, sterically hindered. So can't solvate anionic part. PAS can't solvate anionic part. Why? Because the positive charge is too much sterically hindered, so they will go towards the positively charged carbon. Who will run fast? This is the smallest, this is the largest. Speedily the fluoride will move, and will form the bond. I hope this is clear. Do let me know in the chat section if it is clear why the reverse order got reverse, kids. Now you are able to understand why in polar aprotic solvent the order got reverse, kids. Do let me know in the chat section, green hearts, if you got it. Thank you, Herobrine. Kids, with your comments, with your emojis, they give me strength, the positive energy, kids. And really, teacher is always in need of such type of positive energy, kids. I will give you content. You have to show energy. Everyone, kids. Tamizan, okay. Crystal clear. Silaprasity, Ayarya, Madhumita, very good. Pujashri Devi, Arun, very good, kids. This is the way, kids, really awesome, really awesome. Ravi Kumar, Herobrine, thank you. Pujashri Devi, thank you. Now, kids, let me tell you non-polar solvent. Kids, these are the basics. That's why I'm telling you each and Shubha Lakshmi, okay. Fantastic, fantastic, kids. I'm telling you the basics, then I will explain each and everything so that each and everything should become clear. Now, see, kids, see to it. Now, the non-polar solvent. Let's see non-polar solvent, what it is going to do. Non-polar solvent. See, examples of non-polar solvents are examples. First, let me tell you what do you mean by non-polar. Neither polar nor can donate proton. What is the meaning? Neither polar nor can donate proton. Can donate proton. Neither polar nor can donate proton. This is the meaning of non-polar solvent. Examples are kids. Carbon tetrachloride CCl4, benzene, toluene, etc. kids. Okay. Now, these type of solvent neither solvates the cationic part nor the anionic part. This is very, very awesome thing. These type of solvents means NPS neither solvates cationic part nor the anionic part, neither the cationic part nor the anionic part. Then how they are going to decide that who is going to be the best nucleophile? Remember that the one with least bond dissociation energy, will get released first, and that is going to be the best nucleophile. That is going to be the best. That is going to be the best nucleophile. Now, what is the meaning? What is the meaning of this, kids? The meaning of this is, if I see their bond dissociation energy, hydrogen and fluorine, they are like this, hydrogen and chlorine, they are like this, hydrogen and bromine, they are like this, hydrogen and iodine, they are too far. So the bond dissociation energy is like this. This is having maximum BD. BD means bond dissociation energy, and this is having least BDE. Suppose if I say there is one lion and there is one elephant, but the elephant's rope is very weak. Elephant's rope is very big, and the lion's rope is very strong, and this is lion. Its rope is very strong, very strong bond, very strong bond. This is lion, runs fast but tied with the rope, very strong bond, so can't move. Elephant moves very slow, but its rope is very weak, very weak bond. Who will break its rope first and will kill you? Definitely it will come slowly, like tortoise and hare story will come slowly, but will break this bond. I hope this analogy is going to work. Move slowly, it's like elephant will move slowly, but rope is very weak. He is going to break this rope so easily, so will come like this, and he will eat you like pshaw. But the lion can move very fast, but he's tied. Hey, my rope is very strong, what to do? Kids, you are getting my point? I think this is clear. Done and dusted, kids. Done and dusted. It's being done and dusted, kids. Do let me know. Is it clear to each and everyone, kids? Is it clear? Thank you, Manny. Now, after 10 minutes, I will give you one break, dinner break, okay? After 10 minutes, kids. Now, after this, these many things are clear. Now, let me summarize, kids. Whatever I have told you, let me summarize so that you can easily, you can put it in your brain. So, see to it. If I talk about in polar Aprotic solvent, I have told you the nucleophilicity order: iodide, then bromide, then chloride, then fluoride. This was the order, right? In PPS, this was the order I have told you, kids. Now, if I tell you in PAS, what was the order? I have told you in PAS, fluoride, then chloride, then bromide, and then iodide. This was the order, kids, of nucleophilicity order. Now, in non-polar solvent, I have told you, non-polar solvent, the order was iodide, then bromide, then chloride, then fluoride. I have told you these many things with detailed explanation, right? The solvents types and each and everything. The first polar Aprotic, the second PS, and then the third one. Now, kids, these reactions I have explained. Now, what I am going to tell you, kids, let me show you the SN2 reaction. What I am going to show you, kids, SN2 reaction. Let's set go for SN2 reaction. Baba is going to start SN2. Just see. Now the journey is going to start. The actual chemistry is going to start. SN2. SN2 means second order chemical kinetics. That already I have told you. Meaning is bimolecular nucleophilic substitution reaction. Bimolecular nucleophilic substitution reaction. This is the meaning of SN2. Now see, kids, if I write down one reactant, see, first let me write down general reaction CH3. Let me write down RX plus ENU. What will happen? See, R is having delta positive, X is having delta negative, E is having delta positive, and U is having negative. Now positive and negative will eliminate out. See, positive and negative will eliminate out like this. They will go like this. See to it. Now who is left? Who is left, kids? See, the reaction will be like this. RNU plus EX. Substitution, that R has lost X and got NU. So X is known as the leaving group. Remember that. What? Leaving group. It is going away from the life of R, and nu is acting as nucleophile. It is the newcomer. Nu means newcomer. X is leaving. X is acting as the leaving group. X is becoming X, and nu is coming into the life of R. That we will say R has replaced S and got nu. From the life of R, X has gone. From the life of R, X has eliminated out, and nu has come to the life of R. So this is overall better to say substitution. Somebody is lost, somebody has come to the life of R. Now how it is going to take place, let me explain the stereochemistry so that you can understand each and everything. See kids, let me tell you, let me teach you the stereochemistry. Are you ready? This is the main chemistry, kids. Stereochemistry for this reaction. Once you are able to understand this, you can understand each and everything. So see kids, if I say one valency is coming towards your side, one valency is going away from you, one valency is in the plane of paper, and this is, I am going to say this is X. The polar bond, the polarity is there, and X is having partial negative charge, carbon is having partial positive charge. So I would like to say this bond is being polar bond. Remember that. Why the polarity is there? Because of electronegativity difference. Polarity of bond, polar bond of polarity is there, right? Polarity is there. Now this is known as bonding molecular orbital. If this is BMO, if this is a BMO means bonding molecular orbital. BMO means bonding molecular orbital. Then at the back it will be ABMO, anti-bonding molecular orbital. The bonding one is containing electron, and at the back 180 degree ABMO is empty. It is in need of electron. It is empty, vacant, right? Till now it is clear. Now there is the entry of who? ENU, and let me take any reagent. Let me take like anything. It can be ENU, or let me take C2H5ONA, C2H5ONA. So either you can take like this. So kids, it will attack from the back side. This is ENU. I will write this is E positive and this is NU negative, and this NU will come and attack. It will come from the back side. 100% backside attack will take place. Backside attack will take place. Now the transition state will get formed. What is the transition state will look like? Let's see. The transition state, that in the carbon's life, this is R1, this is being R2, this is being R3. Now, in the life of carbon, I would like to say this is X. Suppose this is X. This is X, kids. This is X. And from the back side, NU will go, this is X. And back side, NU will go and hit it. It will hit it. And it is going to hit it, kids. Now, if it is being stronger, it will hit like this. And now the X will eliminate out from the life of carbon. X has gone and Nu has approached from the back side. You are able to understand or not? Let me tell you, kids, once again, this was X. And from the back side, why from the back side? This X is having electron and this is having electron. There will be electronic repulsion. So can't come from the same side because of the electronic repulsion. It cannot come from the same side, and the ABMO is empty. It will go and attack on ABMO, and if it is being stronger, it will replace this X. And if X is a leaving group, good leaving group, weaker bond, then only X is going to leave this carbon. So this X bond should be weaker, and the strong nucleophile, that should be stronger, then only it is going to replace it. Otherwise not possible. So it will come from the back side and it will start hitting this carbon, and if the leaving group is weaker, it is forming weaker bond, then the X will go away from the life of this carbon, and this is both are rich. This is with electron, that is with electron. Now in the life of carbon, oh my God, carbon's mother started shouting, hey carbon, what are you doing? I have told you, you are smaller, don't keep 5. I have seen that in your life. There are 5 valencies, just manage it. Always remember 4, then only you will be stable. Don't ever keep 5. So this is highly drastic condition, kids. This is known as what? This is known as transition state. This is known as what, kids? This is known as transition state. Highly unstable state, transition state. Remember that this is transition state. Simultaneous breaking of bond and making of bond. This is being breaking of bond. Bob. This is Bob. Bob means breaking of bond, and from the back side there is making of bond. Mob, making of bond is taking place. Both the two things simultaneously, making of bond, breaking of bond, Bob and mob. Now, the valency of carbon is pentavalent. This carbon right now, it's pentavalent. Remember that, pentavalent, highly unstable. This is known as what, kids? Transition state, TS. TS stands for transition state. Now my dear students, valency is 5, that is okay, but its hybridization is still sp2, because this is sp2, this is sp2, this is sp2. The solid bonds are 3 only, the steric number is 3 only, so the hybridization is sp2. Examiner will ask you these things examiner will definitely ask. Till now it's okay. Now see what is going to happen. Kids. The leaving group will eliminate out, and this Nu will say, hey, just adjust and come at 109 degree. Okay. Now carbon will say, okay. Now carbon and this R1 will be on this side. It was on east side, east direction. Now it will come R1 will come on the best direction. Inversion is going to take place. R1, this is your R2, this is your R3, and new will come here. This is new, and see what has happened, kids. Earlier it was sp3, right now also it is being sp3. Earlier 109 degree, right now 109 degree, but the leaving group has gone from the east and nucleophile has approached from the west, and that's why it is known as inversion of configuration. Inversion of configuration. I hope that this word is very much clear to each and everyone. Inversion of configuration, that umbrella is like this. Once too much highly terrible wind is there, then it will go upside down and downside up. That is known as inversion. Let me show you the inversion. Let me try to show you the inversion. If I say the umbrella is like this, too much flow of air, then the umbrella will go like this. This is upside down, downside up, inversion of configuration, this, and it will go like this, inversion. Are you able to understand? If leaving group is going from east side, then the incoming group will come from the west side. If the leaving group is going from north side, then the incoming nucleophile will come from the south. Then leaving group is from east, then coming nucleophile west. The best, right? Everyone getting my point? So this is inverted configuration. But remember that if carbon is chiral, if this carbon is chiral, then this inversion will be known as what, kids? Will be known as Walden inversion. Walden, remember this word, Walden inversion. Then this inversion will be known as Walden inversion. How many of you got it, kids? How many of you got it, really got it? Do let me know, kids. This class is really good for JEE students as well as NEET students. The level is really nalla iruku, kids, romba sulbham. Just see to it. You can take a screenshot of it if you need, kids. Kids, do let me know. Everyone. Yes, everyone. Equally good. Mahalakshmi, it's equally good. Now, kids, I will explain about this after the break. Now it's a dinner break, kids. So let's meet at 10:15, right? I have promised you that I will give one break at 9:30. Kids, okay? Dinner break. So let's meet at 10:15. Okay, kids, is it fine? Just to let me know, kids. Let's meet after the break. Priyanshu, welcome. Kids, we need one dinner break, otherwise, kids, we will die, right? So, one dinner, 10, no, kids. Everyone has to do the dinner. So, it's already 21:40, kids. So, but promise, make a promise that you will come with energy, kids. Everyone has to come with lot of energy, and we have to be consistent. Make that promise, then only I am going to give break. Otherwise, I will not do dinner. I will keep on continuously teaching, kids. Make a promise, then only, kids. Make a promise, then only kids. Everyone make a promise. Okay, kids. Come with positive energy, come with more energy, come with more josh, right, kids? Kids, do let me know. Yes, kids. Hero Brian, you're back. That's really awesome. I'm glad to see that you are back with full-on energy. Kids, how many are with more juice than earlier? Wow, yeah, I have Deepika. I have. That's really awesome. Let's set go. Are you ready? Are you ready, kids? Are you ready? Yeah, I can see the green hearts in the chat section that everyone is full on Josh. So, kids, we were here at this place. So let me check it out that everyone is over there, my dear students. I will tell you the chemistry, the real chemistry behind each and everything. Yes, the chemistry to get revealed. But let me check it out. That how many of you back with the... Yeah, that's really awesome that everyone is over there. Yeah, kids. I can see you. So, let's it go. Everyone is there. Everyone over there. Okay. Madhumita, yes. So let's it go. Kids, let's it go. Okay, let me start. See, that this wants to do this nucleophile. This nucleophile wants to attack in a single step. It wants to attack in a single step. Just see, kids, that this nucleophile, if I talk about this nucleophile, what it is aiming for, this nucleophile is aiming to attack in a single step on this carbon, ABMO. See, this carbon is being surrounded by R1. Must be occupying some space. R2 must be occupying some space. R3 must be occupying some space. Now tell me, if I place all the three hydrogens, in one case, if I place all the three hydrogens, second case, if I place one methyl, third case, two methyls, and the last case, all the three methyls, the bulky group. As the bulkiness of these groups are increasing, the probability of attack of nucleophile will keep on decreasing. Are you getting my point? This nucleophile will find difficult to attack on this carbon as the steric hindrance is increasing. Am I right? So the best attack will be in case of methyl halide, and that's why I have told you SN2 likes 1 degree alkyl halide. Do you remember? 1 degree alkyl halide. Do you remember, kids? Do you remember that point? 1 degree alkyl halide, as I have told you in the starting. Now see, on the basis of that, let me show you the NCRT. Just see, this is NCRT. What I am telling you, that this is 3 hydrogens, so the nucleophile can easily attack on ABMO. 1 methyl, so see, he is feeling a little bit this nucleophile. See, this nucleophile can easily attack. Easy go, easy attack, easy kill. Easy kill. But you see, this hydrogen is coming on the way a little bit because there is ABMO. On ABMO, this nucleophile is going to reach what this hydrogen is coming on the way. So finding a little bit difficult. Its rate is 30 times more than this. It's 1 point, it is 30 times more. Can you see? It's 30 times more. It is 30 times more than that. Now see, 2 methyl groups are coming on the way of nucleophile, then it is just 2 by 100, 0.02. And see, 1 methyl, number of methyls are there, so it is not able to attack it. It's not able to attack. All the methyls, they are coming on the way. So nucleophile is saying, oh no, nalla irukku. What is this? So approximately 0 in 3 degree. Everyone got it? The visualization or the steric hindrance, the stereochemistry. Is it clear, kids? Do let me know. Are you able to understand, kids? Just do let me know. The stereochemistries, visualization. So I would like to say methyl, then ethyl, secondary, then tertiaries. They are not going to. Kids, where are you gone? What is this going on, kids? Focus on your studies. Kids, those who are really good students, let them not to do this. Keep on sending me the messages, the emojis. Everyone. Now see, kids, this point is clear to each and everyone. Now everyone focus on your studies. So remember that, but this is only the NCERT level, the type of R group. But let me give you the level which is required for your best rank. Let me explain that. So remember that. For this, now see the stereochemistry which I have shown you. The stereochemistry. If I talk about stereochemistry, this is methyl halide. One hydrogen is coming towards your side. One is going away from you outside this board. One is the plane of paper, and this is a leaving group. This is your leaving group. Now, this is the nucleophile. This is coming from the back side. Backside attack, 100% backside. Now see sp2 hybridized. 1, 2, 3. 3 sigma bonds are there. So the steric number is 3 and the hybridization is sp2. Now the leaving group is gone and the nucleophile has approached from the back side. Can you see? This is NCERT and this is given C. This is the leaving group going away from the life of carbon, and this is the nucleophile. This is coming from the back side, and this is the transition state, simultaneous breaking of bond, breaking of bond, and this is being making of bond. Now the leaving group has gone and the nucleophile has approached. In this way, the marriage has got completed. This is given in NCERT, and I hope that everyone is able to understand the feeling of NCERT. Everyone got it. Kids, just show me green hearts if really you got it. If you have really got it. If you have really got the feeling of SN2, kids. If you have really got the feeling of SN2, green hearts, green hearts. Now, let me tell you, only NCERT is not sufficient. You have to understand in detail the SN2 reaction, SN2 reactions feeling you have to understand in detail. Just see what's that detail. Let me tell you, kids, type of R, while remaining rest of things constant, type of R, what type of R should be there? The heteroatom, remember that, heteroatom at beta carbon, heteroatom at beta carbon with respect to leaving group, remember that this type of group, kids, this type of group's rate of reaction is going to be maximum, just see how to find out. RO CH2 X, this is the leaving group. Just see, this is the leaving group. This is alpha carbon, this is beta carbon, and any atom other than carbon, the part of ring. Any atom other than carbon, this is known as heteroatom. What it is going to do, that is known as neighboring group participation, anchimeric assistance. That is not in your syllabus, but remember that this is in your syllabus, that its rate will be 10 to power 6 times more, 10 raised to power 6 times more means maximum rate for SN2 reaction, maximum rate. It can be given like that, even it can be given like this also. See, in this way it can be given R C double bond O CH2X. Just see to it. This is alpha, this is beta, and this is being heteroatom. Let me mark it with heteroatom with yellow one. This is your heteroatom. This is your heteroatom. Its rate, it's 10 raised to power 5 times more. This is always cause of NGP effect, but not in syllabus. What? This NGP effect is not in syllabus, but this is in your syllabus. So you have to remember it. Now, after this, there will be your, after these two, there will be your methyl halide, then I will say ethyl halide. After this, I would like to say isopropyl halide, kids, isopropyl halide, and then tertiary butyl halide will not show. So this is the order you have to remember. Its rate is 10 raised to power 6 times, its rate is 30 times, its rate is 1. It is 1 divided by 100 or 2 divided by 100, so it will come out 0.02. And after this there is one more, very less, tending towards 0 only, that is known as neopentyl halide. Neopentyl halide, its name is neopentyl halide. It is 1 degree. Now see, how many of them are 1 degree? This is 1 degree, this is 1 degree. Both of them are being 1 degree. This is 1 degree. This is 1 degree. This is 2 degree. This is 1 degree. But too much sterically hindered, because its carbon is attached with one carbon only. That's why it is 1 degree. But too much sterically hindered. Too much sterically hindered, bulky, and then 3 degree will have 0 rate. I hope that this point is clear. So remember about this. This is very important for your examination, whether it is NEET examination or IIT examination. Remember this. Now let me tell you the leaving group tendency, because we are having the two parts of Rx, R and X. I have told you this already. I have discussed the R part already, we have done. Now let me tell you this, the part known as leaving group tendency. Leaving group tendency. Who can leave easily? Now if your mother is asking, just go once you got selected in your NEET examination or IIT examination. Now that time has come to go to other city. Who can easily go to another city? Those who are too much homely, means can't live without mama and dada, or the one who can live, they can do their work, a little bit of work. Who can live easily? Definitely who is being self-dependent, not too much dependent on parents. That means who is more stable. I would like to say that without mother and parents, if anyone is going away from them, no one is stable. But everyone is away, away from the home is unstable. But comparatively, who is more stable can leave their home safely and easily. Am I right, kids? Now see leaving group tendency. Remember that weaker bases are weaker. Remember that weaker bases are good leaving groups. Now how to find out which are weaker bases, good leaving groups? That means they will leave easily. Now how to find out which one is weaker base, kids? Remember that stronger acids form weaker conjugate bases. Stronger acids form weaker conjugate base. Weaker conjugate base. Now kids, if you can't understand these 2 points, then also there is chance that you can do it. I will help you, kids, don't worry. Baba is always there to help you. Just let me give you one series so that everyone can go through it and can do their work easily. Just see. Just see. Let me write down. See, this is a leaving group tendency. Everyone just see. This is the leaving group tendency. Why I have changed the color? You must be thinking like that. Remember that these starting 4 are very, very strong base. Very, very strong base. So I can say not a leaving group. Not a leaving group, or I would like to say very, very poor leaving group. LG stands for leaving group. Now the tendency is increasing like this. Now I will tell you 2 ways to understand it. Just see, kids, let me tell you how to go through it. But first of all, let me tell you, this is a leaving group tendency. Who will leave first? Triflate and tosylate. I will tell you the structure of triflate and tosylate. Let me write down. This is leaving group tendency. Leaving group tendency, kids. Leaving group tendency. These 2 are the best, or you can say these 3 are the best leaving groups. Now kids, if you are unable to identify all these, you can do one thing. What is that? You just add H plus. You just add H plus to them. They will become like ammonia. This will become ammonia, you can understand, and this will become HI. In GOC, if you know GOC, then HI is the strongest acid. HI is the strongest acid and ammonia is least acidic. Least acidic means its conjugate base is going to be most basic. And here chloride, bromide and iodide. If I tell you, my dear students, if you add H plus to this, it will become HCl. If you add H plus to this, HF, HBr. If you add H plus to this, it will become HI. If you add H plus to this, this will become HF. And you know that the pK values. No, if you don't know, then also you should know the acidic strength order is like this. If the acidic strength order is like this, that means strongest acid conjugate base is being Beker base, and Beker base means good leaving group. Even if you don't know this thing, let me tell you on another page what you're supposed to do. If carbon with fluorine is attached, carbon with chlorine is attached, let me give you the feeling also. Carbon with chlorine is attached, carbon with bromine is attached, carbon with iodine is attached. Now just see, kids. Carbon is of second period. This is also 2p, 2p, great bonding. 2p, 3p, 2p, 4p, 2p, 5p. Which bond is being weakest bond? If you see, just see, kids, which bond is weakest bond? And tell me, this is the weakest bond because this bonding is not great. Poorest bond will break easily. Poorest bond will break easily. So iodide will go and live easily, and this is most stable. That negative charge is most stable on the biggest atom. Remember that people say that Negative charge is more stable on the most electronegative atom, but always see the size first. If the size is more, then negative charge is more stable on biggest atom. Biggest atom means most stable. So this is the best leaving group. Now you will ask about what is tosylate and triflate. Let me tell you what is tosylate and triflate. Kids, see, tosylate means paratoluene sulfonate. Paratoluene sulfonate. What is this paratoluene sulfonate? It will look like this. SO3 negative. SO3H is very strong acid. So its conjugate base is weaker base. Weaker base, go to leaving group. It can also be written like OTS. This is also paratoluene sulfonate, OTS. Now what is triflate? You must be thinking about triflate. Remember that triflate is CF3SO3 negative. Now you see 3 minus I fluorine atoms, they are withdrawing charge. So this is most stable. Most stable means best leaving group. Balaji. What is Balaji? Best leaving group. Now kids, this point is clear. The leaving group tendency is clear to all of you. Just to let me know in the chat section, kids. My dear students, just to let me know this point is clear. The leaving group tendency, weaker bases are good leaving group. I hope that it is clear to each and everyone, kids. Those who are new, smash the like button, kids. What are you doing? Hit the like button, make it 300 at least. What kids going on? You are not listening the class properly, kids. Madhumita, yes, Madhumita is the one. Herobrine is the one. These people are able to understand. Very good, kids. I like these type of students. These are real gem students. Fantastic. Fantastic. Dr. Srill, Nisishan, very good. Eli Neelam, number of kids are there. Tanuja, Shuesh, very good kids, very good. Now, once this is clear, let me tell you the nucleophilicity order already I have explained. So let me frame out questions. What type of questions will be asked in your examination? Just see. Type of questions they are going to ask. See, everyone. Now see questions. What type of questions they will ask? Question. Arrange the following. Arrange the following in decreasing order of rate of SN2 reaction. Rate of SN2 reaction. Okay, ready kids? Are you ready? Just see. A CH3 I CH3 CH2ONA. B is CH3 CH2O CH2 CH2I. C is CH3 CHI CH3. Reagent is same, either write like this or this, they are same. D is CH3, 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 I. Okay, which one will have best rate? Just tell me. Let me check it out in the chat section. Who is going to get the correct answer? Let's see, kids, who is going to get the correct answer, who is brilliant. Kids, do let me know. What's the answer? I'm waiting for your answer. The best one, the best rate. Everyone, kids, I'm waiting for your answer. Kids, fast, fast, fast. BACD, BA, oh my God, Shalu. Oh my God, Shalu has given the correct answer. Oh my God, really awesome. B, yeah, NGP effect will be there. B, then 1 degree, then 2 degree, then 3 degree. Fantastic. BACD. Lovely, lovely, lovely. BACD, the best, the best. Those who have got this answer, they are brilliant, brilliant. Now, second question, just see to it. A, CH3, Cl, C2H5ONA, B, CH3F, C, CH3Br, D, CH3I. Now, let me wait for the answer, or within second I will get the answer. Just let me see my brilliant kids. Who is going to give the correct answer? Fast. Speed up, speed up. Wow, Praveen, West, got it. Herobrine. Fast, fast, fast. I want to see the answer, kids. Fast, fast. Hey, I'm waiting for your answer. This is on a leaving group tendency, LGTP effect. I'm waiting for your answer, kids. I'm waiting for your answer. Fast, fast. Quick. Sahana, very good. DCAB. Herobrine has given the answer DCAB. Let me check it out whether it is right or wrong. DCAB. D, iodide, best leaving group, right? D, then C, right? Then A. Oh my God, Herobrine, absolutely correct. Leaving group tendency based, the best. Now I will mix. I will give you a mixed question. Just see to it. Tougher one. CH3, sulfur, CH2I. Now B, CH3, CH3. My nucleophile is ETOK. Here also ETOK. Now C is CH3, CH3. Now D is CH3, CH2I. Here also the reagent is being same. Now this, let me check it out. Who is going to give the correct answer? Fast. Yes, this time, kids. This time, whose answer is going to be correct, kids? Let me check it out. Kids, fast. I'm waiting for your answer. I'm waiting for everyone's answer, kids. Be fast, be quick, be fast. Tell me the answer, kids. Baba is waiting for your answer. Kids. DCBA. Let me check it out whether your answer is right or wrong. No, here is heteroatom. Just see alpha, beta. At beta there is heteroatom. See everyone, heteroatom. NGP effect, A. It has to start with A. After A, it's D. D is 1 degree and leaving group is iodine. These two are 2 degree. but his iodine is leaving group chlorine, so C, and then it's B. Kids, how many of you got this answer? If yes, you can show me the green hearts. Let me check it out. How many of you got this answer? Now, after this, let me tell you something about SN2 reaction. 2 points, very, very important 2 points about SN2 reaction. Just see to it. Everyone just see to it. Now, if examiner has given you this question, if suppose examiner has given you this question, he has given you this question that here is hydrogen, here is methyl, here is ethyl, and here is bromine, and this carbon is chiral, and suppose it's given that this compound is dextro. This is given. We cannot find out experimentally. This is dextro, this is given. Now, he has done the reaction. He has done the reaction with C2H5ONA. Now, the product will be, he is asking about the product will be. Question is, product will be. Product will be. Option A, dextrorotatory. B, laborotatory. C, racemic mixture. D, only one stereoisomer, either dextro or levo. Yes, this is rank deciding question. RDQ. RDQ means rank deciding question. This is rank deciding question. Let's see who is going to give the answer of this question. That kid is going to be brilliant kid. Let me check it out. Who is going to give the correct answer, kids, for this question? Yes, Baba is waiting for your answer. Everyone, do let me know. Fast, fast kids. Fast. Prasu is going for A. Tanuja is going for B. Tanuja, levorotatory. Shush is going for B. Teju is correct. Teju is correct. It's D. Let me tell you why it is D, kids. Teju is correct. Absolutely correct. Teju's answer is correct. It's D. See, this is SN2 reaction. This is SN2 reaction. So this will attack from the back side. Backside attack will be there. Am I right? Backside attack. Once the backside attack is there, the product will be like this. This will be the product. See, the product will be like this. OC2H5 will come over here. Why? Leaving group is going from, no, OC2H5 will come over here because leaving group is going from this side. So OC2H5 will come from the best side, back side attack. Now this methyl will turn over this side and ethyl will go over here and hydrogen will be here. This is chiral carbon. That was chiral carbon. This is also chiral carbon. But this is not the isomer of this. These two are not isomer of each other because here we were having Br and here we are having OC2H5. It's not the isomer. These two are not isomers. When these two are not isomers, then no relation. We cannot find out this is dextro or levo. Yeah, definitely it will be either dextro or levo. Definitely, if you say, if you just think like this, that if you're doing the numbering, it is going anti-clockwise direction and it is over here. So it is S Definitely you can find out S and R, because here it is going like this clockwise. So this is R. R and S will be dextro and levo if they are isomer, but this is not the isomer of this. This is not the isomer of this, and this is not the isomer of that. That means they are different compound, and in different compound there is no such type of relation. You got it, kids? Everyone, this is really good question. Have you got it? Do let me know. Maximum kids were going for A or B, but answer is D. Kids, how many of you got it? This was really very, very good question. Very, very good question. Kids, if you got it, show me the green signal, green heart, so whatever, green leaves, whatever you can show, green. Let me check it out whether you got it or not. If you got it, green hearts, green leaves, or whatever you want to say, keep on showing, kids, because that is only going to change a scene, or let me understand you are able to get it or not. Yeah, now see, kids, remember that never the racemization will never take place in SN2 reaction. There is only one example in which racemization takes place. Always remember that. What I am going to tell you, just see, kids. Let me tell you the note, very, very important note. Just see to it. The note is, what is the note? Note is, in SN2 reaction, racemization doesn't take place. Racemization doesn't take place. There is only one example. There is only one example. Of SN2 where racemization takes place, where racemization takes place. Do you want to understand that example? What is that example? How many of you want to understand? Sir, we want to understand. Which example is that? Let me give you that example. If they have given you this compound, remember that this compound, iodine is the leaving group, and this is chiral. You see, this is chiral carbon, because all four atoms are different, and the attacking agent is also what? I only, NaI. See, this I will leave, another I will come. The I is the leaving group, I is the leaving group, and I is the nucleophile. One I is leaving, another I is coming, and definitely that will come from the back side. The another I will come from the back side. This will come from this side. So this CH3 will move toward this side, and ethyl will be over here, hydrogen will be over here. Now these two are isomer of each other. And remember that iodine is the only one who is good leaving group as well as very good nucleophile. Remember that. One thing is very clear, I negative is very good leaving group as well as good nucleophile, remember that. So if this is dextro, if this one is dextro, then definitely this one will be levo, because now they are isomer of each other. At T half time, that 50% will be dextro formed, because as this will keep on increasing, this will keep on decreasing. The time will come at equilibrium when this is 50% and that is 50%. 50% dextro, 50% levo, then complete racemization will take place. Complete racemization will take place, kids. complete racemization. Now my dear students, at any other time, not at T half, if this is not T half, at any other time partial, at any moment partial racemization will take place. Why partial racemization, kids? Suppose it has started, this is 80%, that is 20%. So 20% of LAVO will neutralize 20% of dextro. Suppose more time, 60, 40, 35, 65, whatever the ratio, that is partial racemization. But at T half, means half of the reaction has got completed at that time, 50-50, Britannia 50-50. I hope that everyone got it. You got it? Do let me know in the chat section. You got it, kids, fast. Now it's a time to explain the applications of SN2, right? Should I tell you? Or first let me tell you the SN1 reaction and then I will tell you altogether the applications, right? First let me tell you the SN1 reaction, right, kids? Then I will tell you the applications, okay? See, SN1 reaction, unimolecular nucleophilic substitution reaction. This says unimolecular NSR. Now remember that here the order of reaction is 1. In this rearrangement may take place. This I have told you in the starting only. Now remember that. Let me take example number 1. But before I come to this, my mind is saying that let me go back. Let me give the graphical representation of SN2. SN2 is calling me that you have not given the graphical representation. What is that? This is very, very important, graphical representation. Graphical representation, just see, kids. If I say this is the energy, this is the progress of reaction, just see the energy, this is the energy, this is the progress of reaction, kids. Here is the reactant, just see, here is the reactant, kids. This is the reactant's energy. It is going like this and the product has been formed. Just see the chemical kinetics, you will remember each and every point what I am going to tell you. See, kids, if I talk about this is the reactant's energy and this is the product's energy, how much is the difference between reactant and product's energy? You see the reactant's energy and the product's energy, this much is the difference in the two energies. You can see this much is the difference in between the two energies, and that means who is more stable? This is having more energy, reactant is having more energy, reactant is having more energy, and product is having less energy. That means during the reaction energy has been released. That means this much is delta H, negative exothermic reaction. My dear students, remember that this is simultaneous breaking and making of bond. I would like to say this is the transition state. Here simultaneous, what is happening, kids? Breaking of bond and making of bond is taking place. Remember that simultaneous breaking and making of bond. And what I would like to say, that number of transition states is equal to 1 plus number of carbocations formed. So during this reaction no carbocation is formed, So number of transition state 1 plus number of carbocations. So number of carbocations will be equal to 1 minus 1, 0. So there is no carbocation because there is only one transition state. So no carbocation is formed. This is the graphical representation of this reaction. Now let me start SN1 reaction, kids. Let me start SN1 reaction. Just see, kids. SN1. So unimolecular example number 1, which is given in your NCERT. This I'm giving from your NCERT. This is already given in your NCERT. Right? Let's see. They have given like this, that CH3 whole thrice CBr reacting with KOH aqueous, and it has given tertiary butyl alcohol. Tertiary butyl alcohol, right? Plus HBr or KBr plus water, right? It's like given like this. So kids, can you talk about NCERT's mechanism? Can you think about mechanism? Because this is the real thing. If you can talk about mechanism, definitely this reaction will take place. This mechanism or reaction will take place in more than one step, will take place in more than one steps, more than one step. But how, kids? How? Then I will give you number of questions based on this. So this, don't cram it, never cram it. Just think about it, how it is going to proceed, kids. Never cram the reactions, never cram the reaction. Just try to understand how many things are there, how many things are there. One alkyl halide, one KOH, one water, 3 things are there, 3 things. 3 types of entities are given in this question. What are they? One is being Rx, one is being Rx. Suppose this is the beaker. How many types of entities are filled over there? How many entities, how many types of entities are there? Rx is there, KOH is there, water is there, and Rx is 3 degree. Now just think about this 3 degree. Let me draw this 3 degree and think about that. This is carbon, this is the leaving group. This is carbon, hydrogen, 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 carbon, hydrogen, 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 carbon, hydrogen, hydrogen, hydrogen. K plus OH negative is there, K plus and OH negative. OH negative is being very, very strong. Very, very strong what? Very, very strong base as well as nucleophile. Both. This is bunny, base as well as nucleophile. I've told you in the starting, this is bunny. Now it wants to attack from the back side. Now tell me, kids, this is bonding molecular orbital, and at the back of this there will be ABMO. Is there any place? Is this OH negative can attack? Answer is no. This cannot go and can't attack. There is no space. Too much steric hindrance is there. Too much steric hindrance. That means, kids, too much steric hindrance. That means what? That SN2 is not possible. Not at all. SN2 won't be there. Now, if SN2 is not there, then what it is going to do? Nothing it can do. It has to wait. Now water will say, oh dear, just wait. I'm having too much dielectric constant. My dielectric constant is very high. My dielectric constant is very high. So what you will do? Water will say, hey, I know this is polar bond. I will go in between them and I will try to polarize it. I will polarize it, and then I will break bromide from the carbon. I will take away bromide from the carbon. See what I will do. He's saying, just see what I am going to do. Wait and watch. He's saying, hey dear, just wait and watch and just see what I am going to do. Where is the time to hate? Where is the time to love? Someone study. Now see kids. Mechanism. Step number 1. Remember this. Carbocation formation. See kids. Water will come into the life of this tertiary alkyl halide. Water will come and it will start forming bond in between these two. It will start breaking their bond. Who? Water from each and every side will surround this. Now there will be one background music. Slowly come into my life. Slowly just till my bromide. धीरे धीरे से मेरी जिंदगी में आना, धीरे से ब्रोमाइड को चुराना. हौले धीमे. So slowly, quasi, slowly, gradually come into my life. Slowly, just till my bromide. Slowly, come into my life. Slowly, try to still my bromide. So, it will form carbocation, and bromide will go away from the life of this carbon, but it is having only 6 electrons. So it is what? This is highly unstable. So alkyl halide don't want to go forward direction. It will come in the backward direction more, because here it is having 8 electrons. So this is the slowest step, rate determining step. Slowest step, RDS, rate determining. So this is carbocation. Kids, you got it with the feelings? You got it or not? This is reversible step. Oh my God, kids are enjoying it. Kids. What do you call in Tamil? Slowly. What do you call in Tamil? Slowly. What in Tamil slowly known as? Once Sahana told me, but I have forgotten actually. Thank you, Yairea. Telugu or Tamil, do let me know what you call slowly. What do you call slowly, kids? Medhuva, yeah. Medhuva, come into my life. Now see, this is saying Medhuva, ingeva, ebreva, and just bromide, nipo, poda. Medhuva, come into my life. Bromide, poda for my life. Okay, it will go from the life of carbon and water will surround it. Medhuva. Ingeva, water ingeva, bromide nipopoda. Okay, you got it? So, But kids, after leaving this is not, all the alkyl halides are not going to be form the carbocation. This is a reversible step. They will come back also. And after that, there will be one background music. At that time, there is going to be one background music. Juda hoke bhi, because it is coming back. Bromide is forming bond with this, and it is coming back also. So it's singing that background music. Juda hoke bhi, तो मुझ में कहीं बाकी है छोड़ा के पानी का सा, because water has surrounded it from everyone. छोड़ा के पानी का सा तो वापस चली आती है जुदा होके भी. So it is hiding from water and it is coming back. So this step is coming more in the backward direction, going less towards the forward direction, because this is highly unstable. Kids, are you getting my point, kids? Kids, first step is clear to each and everyone. Just to let me know, is the first point clear to each and everyone? Everyone, do let me know. Everyone, just do let me know the first point is super clear to each and everyone or not. Okay, Teju, I will sing in Tamil also. The second step will be in English. The second step is going to be in English, right? The second step, just see the second step. Second step of the mechanism will be in English. Step number 2 will be in English. The song will be in English. Step number 2. This is carbocation. Just see, kids. This is carbocation. And it is having pure p orbital. Pure p orbital, which is above the plane and below the plane. This is pure p orbital. This pure p orbital is perpendicular to the plane. Let me explain how. If this is forming a plane, if this carbocation is forming one plane, if carbocation is forming one plane like this is one plane of carbocation, then you can see that this is going above the plane and below the plane. Can you see, kids? This pure p orbital is going above the plane and below the plane. Is it visible to all of you, kids? Perpendicular to the plane. Can you see, kids? This is going perpendicular to the plane. Can you see, kids? Now this is planar and this is perpendicular to the plane. Can you see, kids? This is perpendicular to the plane. Two lobes are going above the plane and below the plane. I think that it's visible to each and every one of you. Now, kids, this compound is planar. This compound is planar, and pure p orbital is moving perpendicular to the plane. Perpendicular to plane. Now the KOH OH negative has seen OH negative, and bromide, its bromide has gone like this up to this place. Bromide has given. Now see, OH negative wants to attack. OH negative wanna attack. OH negative has seen this carbon. So it is going to come from this side also, and it is going to come from this side also. Now what OH negative is singing the song? OH negative is saying to this carbocation, I am in love with the shape of you. I am in love with the shape of you and thinking of attacking too. I am in love with the shape of you and thinking of attacking too. Now what this carbocation is saying? Carbocation is saying, I'm being planar. I'm being plainer with pure people, pure be. I'm being plainer with pure people, pure be. How much do you love me? Come and attack from both the sides. How much OH negative you love me? Come and attack from both the side. Two lobes. Kids, got it? Got it, kids? I'm in love with the shape of you and thinking of attacking too. In Hindi, it is saying, कितना प्यार है तुमको हमसे जाने जाना, दोनों तरफ से अटैक करके बताना, दोनों तरफ से अटैक करके बताना. How much do you love me? Do let me know. How much do you love me? Do let me know. And come from both the sides. Kids, are you getting my point? Thank you, kids, thank you. Because these OH negative will attack on this orbital. One will come and attack over here, this will come and attack over here, and this will come and attack over here. They will give their electrons to these orbitals. So kids, there is number of questions you are going to get in your examination based on this. Number of questions you will get in your examination. Just let me show you, kids, that from which side the attack will be more. Let me tell you, this attack will be less and this will be dominating. Why this is dominating? Let me tell you why this is dominating. See, there is a repulsion. X is moving, X is going, new is coming. X is going, new is coming. X is going, new is coming. There will be fight if this new is coming from the same gate. If new is coming from the same gate, there will be fight. If new is getting entry, from same gate, then there will be fight. Then there will be fight. There will be fight in between whom? In between X and leaving group. Electronic repulsion will be there. Am I right, kids? Electronic repulsion will be there. But this, no one is over here, so this will come and attack in more amount. So back side is dominating. Remember that back side attack is dominating. Back side attack is dominating. Back side attack is dominating. Attack is dominating. Attack will take place from both the sides, but this is dominating. Back side attack is dominating, and this is minor. This is major, that is minor. This is minor attack. I hope you got it. Now once the attack is there, let me show you on next page. That retention and inversion of configuration. So let me draw the same carbocation. If I draw, this is CH3, I can draw like this also. CH3 plus charge, and this is the lobe from which side the leaving group has gone, the same side from which side the leaving group has gone, and this is the opposite side of the leaving group. So this is known as front side attack, because the leaving group has gone from this side also, this side only, not also, this side only. So this side attack will be known as what? This attack will be known as front side attack, because it is coming from the same side, front side attack. And this is minor one, this is minor, and back side attack is major one. Back side attack is being major one. Just see this back side attack is major. This is back side and this is major. Now I'm going to form the product, backside major. But till now, is it clear? Attack will always take place in ArSN1 reaction from both the side. Front side attack and back side, both the side gets. Both the side attack will take place. So both the side attack will take place, but the front side is minor and back side is going to be the major. That means you are going to get two types of products. You will get two types of products. Let me write down those two types of products. One type of product you will get methyl COH. This is known as retention of configuration. Retention, I would like to say this is being retention of configuration. And the another one is, this is inversion of configuration. How to find out retention and inversion? This is the side of the leaving group. Same side the leaving group has gone. The leaving group side is known as retention, and the back side, opposite of that, inversion of configuration. This is major one, and this is known as what? Inversion of configuration. Inversion of configuration. I hope you got it. Now, let me give you the second example, but before that, let me tell you the graphical representation of this. Graphically, how to see it graphically. Just see the graphical representation of this reaction. Let me write down, because they will ask you, number of questions will be asked on this. This is the energy kits. Energy is increasing like this, and progress of reaction like this. Now let me take the reactant. The reactant is like this. If I say this is being the reactant, this is being the reactant, and it is moving like this. Da da da. Na 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 na. Yeah. See, just see. This is reactant. This is being reactant. Oh ho ho. Ha ha ha. This is being reactant. And this is being product. What was your reactant? The reactant was like this. CH3 whole thrice CBr. What is the product? CH3 whole thrice COH. Now, just see kids. This is transition state number 1, and this is transition state number 2. You can consider like hill and valley. If you have seen hill and valley, that two hills will make one valley. Two hills will make one valley. You know that. So this is your intermediate here. It's your intermediate. This is intermediate. Now see. Just try to understand the number of steps in which reaction has proceeded. This is transition state. Number of steps. So you have seen in how many steps the reaction has taken place. 2. So number of steps is transition state. And I have told you number of transition states. Number of transition states is equal to 1 plus number of intermediates. So you can see how many intermediates have been formed. How many intermediates? One intermediate means how many transition states? 2 transition states. I think it's clear. You can see that it's just see. Let me tell you in another version. Just see, these are the mountains. Just see, these are the mountains. If I show you, these are the mountains. Just see, what is this? I'm unable to make mountain. These are the mountains. How many valleys will be there? If there are one peak, there is two peaks, there are three peaks, there are four peaks. How many valleys will be there? The peaks are being transition states. Transition state, transition state, transition state, transition state. So 4 peaks are there, then definitely one less will be the number of intermediates. 1, 2, 3, only 3 valleys. So this is intermediate number 1, intermediate number 2, intermediate number 3. So intermediates are 3. So definitely transition state will be more than 1. That means 3 plus 1, 4. I hope this point is clear to all of you. This reaction is an example of SN2 or SN1 multi-step reaction. So definitely you will tick over there. Multi-step means it is not SN2, it's not SN2, it is SN1 multi-step. I hope this is clear. Just to let me know in the chat section, is it clear to all of you? Gets it been clear to all of you or not? Everyone, just to let me know it's clear or not. Gets, do let me know, everyone. Everyone, just to let me know. Fast, fast, kids, fast. Thank you, Teju, thank you. Really thanks, Teju. Kids, call everyone. Baba is giving you quality content. Baba is really giving you quality content, kids. I'm putting lot of efforts so that everyone can understand, kids. Now see, kids. Now see, kids. If examiner is giving you this example, see, if examiner is giving you this example, just see. Bromide, hydrogen, methyl, phenyl. Examiner has given you this carbon is chiral. Can you see this carbon is chiral? Now he has given you the same reaction, KOH aqueous. Now what you will do, kids? Definitely first you will form the carbocation. First you will form the carbocation. First you have to form the carbocation, and then second step OH negative will attack. So you will get two types of products. What are these two types of product? One, retention, so OH at this place. This is chiral. Another inversion, inverted product OH on the another side. Now this is inversion. So two types of products we got. This is a retention of configuration. This is inversion of configuration, right? Now kids, this will be major product. That will be minor product. But kids, just see, both the carbons are chiral. Both the carbons are chiral. That means these two are what? See, they are isomer of each other. And if they are isomer, if they are being isomers, then I don't know which one is dextro, which one is levo. That we don't know. No one can find out. Dextro and levo is experimentally determined. But we can find out one thing. If this is dextro, then that will be levo. If that is dextro, then this will be levo, because these two are non-superimposable mirror images of each other. These two are non-superimposable mirror images of each other. Non-superimposable mirror images of each other, right? These two are non-superimposable mirror images of each other. So they are really enantiomeric pair. They are really enantiomeric pair. Am I right? So if this is dextro, that is levo. If this is levo, that is dextro. What I want to say, they are dextro and levo. So racemization will take place. So it is an example of racemization. You got it, kids? I don't know how much percentage, partial or complete, we don't know. Now you will say, sir, how complete racemization? How complete? Let me tell you, kids. Let me tell you one rank deciding thing. Rank deciding. If this is clear, then I am going to tell you rank deciding thing, kids. Remember that this is only for rank lovers, rank deciding. If you want to get top 100 rank, then only it's for you, otherwise not. Rank deciding. That rate of reaction, rate of SN1 reaction is directly proportional to stability of carbocation. That is okay, all right. Fine, fantastic. As well as the polarity of solvent. Okay. Now, what I want to tell you, kids, $1 million thing I am going to tell you. Just see, wait and watch. What is that? Kids, remember that. Now I am going to tell you another thing that holds a hell lot of weightage. That extent of racemization is directly proportional to the stability of carbocation. This point try to understand, kids. This is very, very important. I know that you are not able to understand right now this point. I hope that you are unable to understand. Am I right, kids? Right now you are unable to understand this point. How many of you are interested in understanding second point? First point to everyone knows. The first point to everyone knows. But the second point only OP people can understand. And I will make this point very much clear to all of you. If you want to understand, then do let me know. You are interested? You are interested? Are you interested in this to understand this point? This holds a hell lot of weightage, kids. This holds a hell lot of weightage, kids. How many of you are interested in understanding this point, kids? Okay. 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 Oh my God, Virat Sheikh. Now see, kids. Just try to understand if I tell you that. First, let me write down that I am having one carbocation like this. CH3. CH3. H positive. I'm having another carbocation like this, C positive, CH3, CH3, CH3. I'm having one more carbocation like this. So let me change these groups so that racemization can take place. Right now racemization can't take place, and that also racemization right now can't take place. So let me change the groups, C2H5. Oh. Carbon, CH3, C2H5, H positive. Another carbocation like C6H5, CH3, H. Another carbocation like this, OCH3, methyl CH3. Now the stability of carbocation we know. If you don't know, then let me write down the stability of carbocation is in this order. This is the stability of carbocation. This is maximum stable carbocation, right? And this is least stable. Now, if somebody wants to go away from your life, what you will say? If somebody wants to go away from your life, then you will say, if you can't live without that person, place or thing, you will say, oh, please don't go. But if you can live, then you will say, oh, go, 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 poda. जाती है तो जा, भाव मत खा. Otherwise, if you can't live without that, तेरे लिए ही जिया मैं, हम तेरे बिन रह नहीं सकते, है नहीं? The song you will sing like that. So this is least stable. This will say, hey living group, please don't go far away. Please wait, somebody is going to help me. So this will say, I'm stable. If you want to go, just go away. So his bromide will go this much away, and this is saying, hey, I'm not in need of you at all. Go wherever you want to go. So his bromide will go this much far away. This bromide is only this much far away. This bromide has gone this much far away, and this bromide has gone so far away, so not visible, invincible, invincible, right? Now, from which side the OH negative can come easily? The OH negative will find easily to come. This OH negative, there will be fight. Oh my God, this OH negative, okay, and this OH negative, the way is 100% clear from this side attack and 100% clear from this side. So Britannia 50-50, 50% from this side, 50% from this side. In this, I would like to say, if from this side 40%, then from this side 60%. Percentage we can't find out, what I am telling you. But here, maximum from this side only 90% or whatever the percent, and this is very less, 10%. But I'm telling you, the attack, front side attack will keep on increasing. Front side attack, just you see, the front side attack, front side attack will keep on increasing, but can't be more than backside attack, means can't be more than 50%, but can't be more than, but can't be more than 50%. Means can't be more than backside attack. How many of you got it? How many of you got it? Just to let me know in the chat section that as the stability of carbocation, increases, as the stability of carbocation increases, the extent of racemization will increase. In case of 50-50, there will be more racemization. How many of you got it, kids? So, Telugu industry, Samsungo, unknown user, everyone is able to understand. That's really awesome. That's looking great. Great, guys. Great. Fantastic. Fantastic. Now, kids, let me tell you one more thing, or let me tell you first this thing in detail so that everyone can understand each and everything with clarity. Now, so let me tell you one statement, $1 million statement. Let me tell you, kids. Let me tell you $1 million statement first of all. That statement is in SN1 reaction, attack takes place from both the sides. Attack is from both sides. But backside attack, attack is dominating in 90% of the reactions. This is valid for 90% reactions, kids. Till now you must be thinking that this is valid for 100% reactions, but now today I have told you that this is valid for 90% of the reactions. Then what about 10% of the reactions? In rare cases, that is 1 to 10%, attack is 50-50. Attack is equal from front side as well as back side. Kids, remember that. That is Britannia 50-50. This happens in most stable carbocations. But kids, it is experimental based. We cannot tell it theoretically. By simply seeing the example, we can't say in which case it is going to happen. So it is experimental basis, experimentally determined. Experimentally determined. It should be given experimentally determined. So it must be mentioned, otherwise we will take 50-50 if it is not mentioned. Kids, you got it? Just to let me know in the chat section these 2 points. Clear, crystal clear, kids? Kids, do let me know. Kids, do let me know. Everyone just do let me know. Everyone just do let me know, kids. Very good, kids. Very good. Now, so let me tell you the applications of SN1 and SN2. But before telling you the applications, let me deal with ArSN2 reaction, right, kids? Let me tell you ArSN2 reaction before telling you the applications of this. But before that, let me show you the NCERT example. Inversion, retention and racemization. See, inversion, retention and racemization, all the 3 points I have done. Cleared or not, kids? Up cleared or not? See, inversion, retention and racemization. This is one compound. You see over here, you see A plus B. No, you are not able to understand. Just see, this is hydrogen away from you and this X is on left hand side. You see everything is on its position, but here Y has come. In place of X, Y has come at the same position. What you will say, retention or inversion? The X has gone and X has been replaced by Y at the same place. You will say this is what? Retention. Here you see hydrogen has shifted on this side and Y has come on the right hand side. It is on the left hand side, you see, left hand side. This is also on the left hand side, but it has come to right hand side, right hand side. So what you will say? And here A and B both are formed. So this is racemization. Racemization has taken place and there is retention, retention kits. And here it is inversion of configuration, inversion of configuration. I hope that this point is clear to each and everyone. You got it, kids? Everyone got it? Very good. Now see, kids. I was about to tell you ArSN2 reaction, then I will tell you the applications, right? ArSN2, very, very rare reaction. ArSN2 is rare reaction. Just see, kids. Rare reaction. Takes place only in halobenzenes, only in halobenzene. And drastic conditions, in drastic conditions, kids, drastic conditions. Now just see, if I write this type of compound, what do you think? What product will be formed? And if I write down here NaOH, what do you think? What type of product will get formed, kids? Remember that no reaction will take place. No reaction, kids. No reaction. No reaction at all. Now see, kids. This lone pair is doing resonance with benzene. Can you understand, kids? Lone pair is doing resonance with benzene. Now, if it is going to come over here, it will shift over there, then it will form resonating structures. Now, just see, the actual structure of halobenzene will be like this. If I draw all the resonating structures, electron will come at this place, this place, this place, and electron will move like this, and this single bond will get partial double bond character. Can you see, kids? Now dotted, 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 you see single bond will develop partial double bond character, so the bond strength is more. As single bond, this single bond develops partial double bond character, partial double bond character, kids. So what should I say? Its single bond is not pure single bond, it is having something double bond character. That means the bond length will increase or decrease, kids, do let me know. The bond length will decrease, bond length will decrease, and in NCERT it is given that it decreases by 8 picometer, decreases by 8 picometers. So definitely the bond order will increase, bond order will be greater than 1, so the bond strength will increase, bond strength will increase. Now the bond has become stable. It is looking like this, but it is very, very strong bond. Now anyone is going to give you, anytime if anyone is providing you halobenzene, then what will you say? The bond strength is very high or less? They will give you like this. They will give you halobenzenes like this, but you have to see halobenzene like what? They will give you halobenzene like this, but you have to see halobenzene like this only, or you will see halobenzene always like this. The one who is intelligent will always see halobenzene like this. The one who is intelligent will always see halobenzene like this. Kids, do let me know you are able to understand or not. That single bond, it's not the single bond. This is wrong. This is wrong. This is wrong. It's not single bond. It's not single bond. So you have to see like this. Single bond is having what? Single bond is having what? Kids, do let me know. Single bond is having partial double bond character. Single bond is having partial double bond character, because very, very important thing, kids, very, very important. Now that's why the halobenzenes do not show SN2 reaction or nucleophilic substitution reaction easily. Kids, that's why, remember that, that's why this is the reason, this is the main reason why halobenzene do not show NSR under ordinary conditions, under ordinary conditions, right kids? Under ordinary conditions. Now kids, somebody can also give you like that, if whenever halogen is attached to sp2 hybridized carbon, then always this situation will arise. Whenever halogen is attached to sp2 hybridized carbon, it is going to act as poor leaving group. This X will always be a poor leaving group, not a good leaving group, poor leaving group. Now what to do to make this reaction possible? How this reaction will take place? That is a $1 million question, kids, isn't it? Kids, you are there? Who is there? technoblade. Okay, whenever somebody is doing anything, if somebody is doing anything wrong, kids, you can put number of what emojis, green hearts, then he won't be able to put many messages. Whenever somebody is trying to do any spam, you can do what? You just keep on showing number of green hearts, then that person won't be able to spam. Whenever any person is writing anything or doing anything wrong, you can put number of green hearts, then that kid will always, that will go away, won't be able to do anything. That is the best remedy. So these are the peoples who have taken money from somewhere. These are the people who got money from somewhere, 2 rupees, 3 rupees, and they are doing like that. For just for 2-3 rupees, they are doing like this. Okay. So whenever anybody is doing like that, you can keep on sending number of emojis, then he won't be able to do anything. Okay. Okay. Thank you kids. Now see, this type of reaction is given on page old NCERT, page number 303. And what reaction is given, let me show you. Let me show you those reactions. The first reaction, let me tell you, the halobenzene, like chlorobenzene, and they have written like this: NaOH, 623 Kelvin temperature, 300 atmospheric pressure, and then H plus, and then you will get phenol. Now kids, this one reaction they have written. The second reaction they have written like this. The second reaction they have written like this: Cl and NO2, and this time a little bit less temperature is required, like 448 Kelvin, and H plus. You got paranitrophenol. Now they have written the third reaction. How they have written, kids? Let me tell you. The third reaction they have written like this: OH, NO2, NO2. Now they have used NaOH and 368 Kelvin. Now they form like this. And the third reaction they have written on page number 304. What's that? What's that? They have turned the page and they are saying that if we do the reaction of this compound, see, I think chlorine I have to use here. Chlorine, not OH is not there, chlorine is there. Now they have written this reaction that if we place 3 NO2s, then the reaction will take place at room temperature only, simply using warm water, not even to use, no need of even NaOH. This reaction will take place by its own. Picric acid will get formed. Now kids, number of questions are arising in our brain that what NO2s are doing, how this reaction is taking place even at room temperature, and they are not in need of NaOH. Number of questions are arising or not? So we have to understand the mechanism. How many of you are ready? How many of you are ready to understand the mechanism, kids? Do let me know, kids. How many of you are ready to understand the mechanism, kids? How many of you are ready to understand the mechanism, kids? How many of you are ready, kids? Good morning, unknown user. Good morning. How many of you are ready, kids? Do let me know. How many of you are ready to understand the mechanism of this? Good morning everyone. Good morning, kids. Good morning. Now, good morning everyone. Good morning. Now, how many of you are ready, kids? To understand the mechanism, just see. See. Let me write down this reaction, kids. Here is chlorine and this is NaOH. Now see, kids, Na positive, OH negative. You have given 300 atmospheric pressure, 623 Kelvin temperature, too much temperature from lower side. Molecules will try to go far away, and you are applying at the same time pressure from upside pressure, downside temperature. Then where they will go? They will not get any space. From downside heat, they will try to move far away. From upside pressure, they won't be able to move any side. Now, what will happen, kids? This bond will break. Now, the question arises, why only this bond will break and this will shift toward this side? Why only this bond is going to break and why only it is going toward this side? $1 million question. See, kids. You will get answer of all the questions, but before that, let me tell you one thing. What's that? Why the OH negative is not attacking from backside? Why not SN2? Because there are number of pi electrons, so OH negative can't attack. OH negative can't attack from this side, can't attack, so no SN2. Now, why question arises, why its carbocation is not getting formed? Number of questions. See, kids, if this is going to form carbocation, then the plus charge will come on the double bonded carbon only, and this plus charge on double bond is highly unstable. Whenever you have plus charge on double bonded carbon, this is highly unstable. So no SN1, no SN1, no SN2, no SN1. So this, why this is formed? Because this plus charge will get support of these electrons, so stabilized by back bonding. It is stabilized by what? Stabilized by back bonding. That's why. So in ArSN2 reaction, neither backside attack nor front side attack, sidewise attack will take place. The OH negative will attack from sidewise like this. Sidewise attack. This is known as sidewise attack. Sidewise attack will take place and it is going to form carbanion. It will form carbanion, and remember that reversal backside attacks, backside reversibility of reaction will be more. Now this is chloride, this is OH, and the position is like this. Just see, first time the intermediate is carbanion and it was aromatic. See, the reactant was aromatic and it has lost its aromaticity. Now it is It is. You will say anti-aromatic? No, this is sp3 hybridized, so non-planar. Non-planar means non-aromatic. So earlier it was more stable, but now it is less stable, kids. So nobody wants to become less stable. So I would like to say this is the slowest step, rate determining step. Slowest step, RDS, rate determining step. Till now it's clear. Do let me know in the chat section first of all, everyone. Till now it is clear, kids. Do let me know, kids. Everyone just do let me know. Everyone just do let me know that till now you got it or not, kids. Everyone just to let me know, kids, till now. Now, after this, kids, after this, what is going to happen? Let's see the second step. Let's see the second step. What is going to happen, kids? See. In step number 2, but remember that in this reaction something has happened great. The halogen, the leaving group is still there. In SN1 reaction, halogen was left. In SN2 reaction, halogen was left. But here in the rate determining step, halogen is still there. Halogen is not gone. Not gone. Now let me tell you step number 2. Now kids, there is halogen chloride, there is OH negative, and it's like this. Now this is sp3 hybridized. Now my dear students, Na plus will approach this chloride. Now why Na plus will approach? Now why it will go? Now see, this carbon is sp3 hybridized and the lone pair of chlorine can't do resonance with the benzene, and this is not benzene. So lone pair are localized. Localized means not participating in resonance. Lone pair or pairs can't do resonance. Can't do resonance. Right? So Na plus will approach and take away this chloride. Along with the electrons, this chloride will get away and you will get plus, and plus minus will form a bond, and this is going to be the fast step, kids. Fast step, right? This is the fast step, kids. Once again it has become aromatic. Now kids, one more question is there. Before I letting you know the mechanism, one more question. Why H plus was added? What was the role of H plus? H plus is added. Role of H plus. To neutralize the excess amount of NaOH left And if you are not going to neutralize the excess amount, then if you're not going to neutralize, then what is going to happen? That NaOH will attack on this acid, carbolic acid. This is carbolic acid. NaOH will attack on this. And due to acid-base neutralization, sodium phenoxide will form, and you won't be able to make phenol. In that case, you won't be able to make phenol kits, right? Now, let me tell you the factors which are stabilizing this reactions rate. Now kids, let's see the factors which are stabilizing the rate of reaction. Are you ready kids? To see the factors which are stabilizing the rate of reaction. Is everyone ready kids? Everyone ready kids? Do let me know. Do let me know kids, is everyone ready to see the factors which are responsible for making this reactions rate more? Now see, very interesting kids, very interesting. See, just see kids, very interesting. See kids. Factors affecting rate of ArSN2. What is the meaning of ArSN2? I haven't told you. A for aromatic. Oh, ArSN1. It's written ArSN1. Till now it's let me change. It's written SN1. It's ArSN2. I have to make it ArSN2 because right now I am teaching ArSN2. 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 Right? So ArSN2 meaning is aromatic. ArSN2 meaning is what? Aromatic. Bimolecular. NSR, nucleophilic substitution reaction. Okay. Now factors affecting ArSN2's rate. Factor number one, resonance. Factor number one is resonance. And factor number two is inductive effect. Now let me explain one by one. First let me explain this factor number one, resonance, because it is very important kids. It holds a hell lot of weightage. Just see to it. see kids. If I am having this compound, negative charge is present at this point, and this point, and it's like this, that I am having chloride, I am having OH. Now if I attach kids, if I put here what? If I put here NO2 group, what it will do kids? If I add over here NO2 group, then it will allow this negative charge to go at this double bond also. My negative charge will do resonance at this place also kids. It will do resonance at this place also. Now if I add NO2 over here, then this negative charge will do resonance over this pi electron and all the atoms. It will do resonance at this place also kids. And if I add NO2 at this place, means ortho and para with respect to halogen, then my negative charge will go and do resonance at this place. That means the delocalization will be over this much of area. The delocalization of pi electrons will be in this much of area, that my electron will cover this much of area, this much of resonance, means this much of extra resonance will be there. Just see, earlier the resonance was only in this much of area. Earlier the resonance was only at this much of area, this much of area. Now the area of resonance from this red point to green point has been increased or not? The delocalization area, do let me know, the delocalization of area got increased or not kids? Do let me know. The delocalization of area, kids, delocalization area got increased or not? Kids, do let me know. Till now, whatever we have seen, the delocalization area, the delocalization of part got increased or not kids? Do let me know. Increased or not kids? The area of delocalization, the area of delocalization got increased or not kids? Do let me know everyone. So the resonance area got increased, that the stability of carbon ion got increased. The area of delocalization increased. The area of delocalization of pi electron increased. So the stability of carbon ion got increased, hence the stability of carbon ion increased. And hence the rate of reaction also increased. Rate of reaction also increased. Kids got it? These NO2 type, like NO2 is what? NO2 is acting as minus M. NO2 is acting as minus M minus R, that is electron withdrawing group. So all the electron withdrawing group, if they are placed at ortho and para position with respect to leaving group, ortho and para position with respect to leaving group. So remember that any electron withdrawing group that is minus M minus R when present at ortho or para or at both, then it will stabilize ortho and para with respect to leaving group. Ortho or para or at both with respect to halogen. Remember that, with respect to halogen. This is the point to be noted, my lord. Then it will stabilize carbon ion and increase the rate the rate of reaction. Will increase the rate of reaction. One factor, this is most dominating factor, that is resonance. Kids, this point is clear, super clear to each and everyone? Do let me know. Is this point super clear to each and everyone? Kids, do let me know. Now kids, this point is super clear to each and everyone. Kids, is this point super clear to each and everyone? Kids, do let me know. I think you got tired, kids. What happened? You got tired. Only few students are there, I think. What happened, kids? Where are you? Kids, is it clear? Now see, kids. Second factor number 2. Inductive effect. Factor number 2 is inductive effect. Now let's see, this was the benzene, this was the carbon ion, and this was the halogen, and this is the OH. Now this halogen is withdrawing electron through minus I effect, and it is stabilizing the carbon ion. The charge is decreasing and the stability of carbon ion is increasing. And the rate of reaction is increasing. Now kids, by considering all these points, I am going to tell you one order. You will be shocked with that order, that how this order is possible. Okay, so let me tell you the order, then I will give you one break. Okay, let me tell you the order, then I will give you one break. Okay, kids? Yeah, kids, I think people got tired. So should I give you a break? Because I have not given break, kids. I think that people need break. I have not given any break. I think that's why. Okay, so let me give you a break. Okay, what's the time right now? It's 1:25. So let me give 15 minutes break, okay? So let's meet at 25, 30, 40. So it's a break. Short break, kids. Twelve, 45. A short break, okay? Okay, kids? Do let me know in the chat section. Do let me know, kids, okay? So kids, are you back? Just to let me know, my dear friends, everyone, just to let me know in the chat section, are you back? Should we start? Are you ready? If yes, I want to see fire in the chat section. My dear friends, I want to see fire in the chat section so that, yeah, that's fantastic. I can see some emojis that kids are back. Just I will take 1 hour more. One more hour, kids. Just 1 more hour to complete each and every reaction. I will give you memory chart. So in 1 hour, I will complete each and everything. I want to see some fire in the chat section, kids. And I will complete rest of the reactions through the memory chart. So yeah, so everyone is there. Yes, let's go and let me tell you. Let me give you the order for this ArSN2 reaction. Let me give you the order for ArSN2 reaction. Just see the order is over here. So at number 1, it's your fluorine, kids, fluorine. Now you will ask, why fluorine? Kids, first let me give you the simple order. Fluorine, fluorobenzene is maximum reactive. Now my dear friends, what I am saying, who is going to apply maximum minus I? Fluorine will apply maximum minus I. So after that chlorine, then after that bromine, after that iodine. Now kids, some of you might be thinking that, sir, how this fluorine to never is the leaving group, kids. This is very special reaction. In this reaction, let me see, everyone is back. Yeah, everyone is back. Fluorine, you must be thinking the order is wrong. The order must be on that side. But kids, the order is on this side only, because this is absolutely correct, because in the rate determining step, fluorine has not gone. And this is the beauty of ArSN2 reaction, that fluorobenzene is maximum reactive. This is maximum reactive for ArSN2. Maximum rate for ArSN2, kids. It is very important thing. This is having maximum rate for ArSN2 in other reactions where fluorine was not the leaving group, but here fluorine is stabilizing the carbanion. So this is absolutely correct. So here rate leaving group tendency is not the part in the rate determining step. Remember that here the leaving group tendency is not deciding the rate of reaction. Why, kids? Because leaving group is not the part of RDS. It's not the part of RDS. It's not the part of RDS, rate determining step. And fluorine is stabilizing the carbanion. Fluorine is having maximum minus I. Remember that. So stabilizing maximum carbanion. So stabilizing carbanion up to maximum strength, up to, no, this much is clear. So this is having maximum rate. I think this point is clear to each and everyone. Just to let me know, this point is clear. Now my dear friends, now let me tell you the whole order. So if I place here fluorine, then 3 NO2s, this will have maximum rate for ArSN2 reaction. After this, I will say if I place chlorine and 3 NO2s at orthopara with respect to leaving group. After this, I would like to say the chlorobenzene and 2 NO2s. After this, I would like to say chlorobenzene, then 1 NO2. Now I would like to say the bromobenzene, NO2, then iodobenzene and NO2. Now, my dear students, if I say after this, if I place any electron donating group, then that will decrease the rate of reaction. If I put any electron donating group like this will act as plus M and plus R. This is electron donating group. It will decrease the rate of reaction. So this is the order. I hope that everyone, this is clear to each and everyone, and you can understand. Now you can answer any question for ArSN2 reactions rate. They will give you question. You can see it from here and you can answer it. You can answer any question for ArSN2 reaction within fraction of seconds. This is the order in decreasing order, and this is having the maximum rate and that is having the least rate. This is now clear, kids. Wow, everyone showing me some fire. That's really awesome, kids. That's really fantastic. Now, my dear students, let me tell you, let me give you the memory chart for ArSN1 reaction. ArSN1. See, ArSN1. ArSN1. First, let me tell you which is ArSN1. You see ArSN1, page number 396, 97, 98, old NCERT. This reaction is very rare. Very. First, let me tell you the meaning of aromatic unimolecular. Aromatic unimolecular NSR, nucleophilic substitution reaction, and this reaction is very rare, kids. This reaction is very rare. Why this reaction is very rare, kids? Let me tell you. Very rare reaction, and this is possible only with one very special compound, benzene diazonium chloride, benzene diazonium salts, benzene diazonium salts. Kids, this 100% 2 questions you can expect from this one memory chart I am going to give you. Benzene diazonium salt. I will give you one memory chart and definitely 2 questions will come directly from this benzene diazonium chart. Now, how the reaction is going to take place and what is the formula for this benzene diazonium salt. Remember that, and this is known as diazo group. This is known as what? Diazo group. And benzene diazonium salt structure is this one. This one is benzene diazonium salt structure, kids. This and X negative benzene diazonium salt. In short, we can say BDS, benzene diazonium salt. Now, tell me, do you know anything about it? First, let me tell you that this benzene diazonium, how it is going to get prepared. If you are having aniline, remember that aniline, and you react with NaONO, kids, you know Nano, who's the owner of Nano by chance? Nano, you know Nano, kids, Nano. nano NaNO2, NaNO2, Tata ji, nano HCl. The temperature you have to take 0 to 5 degrees Celsius, 0 to 5 degrees Celsius, ice cold solution, ice cold solution. Then it is going to produce HNO2, HNO2, nitrous acid. Remember, anything either that or this is given, this will convert into nitrosonium ion, nitrosonium ion, the actual attacking agent, nitrosonium ion. Either this is given, this is given, this is given, all they are known as diazotization. What it is known as? It is known as diazotization, 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 diazot, diazotization. You will get benzene diazonium chloride, and this benzene diazonium chloride is stable only at room temperature. No, only stable at 0 to 5 in ice cold solution. 0 to 5 degrees Celsius. If the temperature is going to get increase more than 5 degrees Celsius, oh, it is 2, 0 to 5 degrees Celsius. The temperature is going to increase, that N2 will get eliminated. N2 will get eliminated, kids. Now what is happened? If N2 is going to get eliminated, then remember that why N2 is getting eliminated. Remember that N2 is the only group which after eliminating will form N2. This will go and this will form N2, N2, N2. Now kids, N2 is the best living group, super best living group. Kids, remember that, super best living group, and this is the only reaction in which phenyl free radical is formed, and better to say here positive charge. Then I will tell you send me reaction, and this is highly unstable because any charge on double bonded carbon is highly unstable, highly unstable, highly unstable. Now it will very fastly, this is the rate determining step, RDS. Why rate determining step? Because from stable thing is getting converted into highly unstable, highly unstable. And it will react very soon with any nucleophile, so you will get product, you will get product. Now let me give you the memory chart. Till now everything is clear, fit and fine, kids, everyone. Yeah. Just let me give one memory chart. Just let me give one memory chart, then it's okay, okay? Kids, just let me give one memory chart, then it will be okay. Okay, kids, just last memory chart let me give of ArSN1, then it will be okay for today, right, kids? Just see, the two questions definitely will come from this lecture. Two questions definitely will come from this lecture, not this whole lecture. One memory chart I am talking about, two questions from this memory chart. Just see, this is benzene. Now I want to prepare nitrobenzene from this benzene. What I am supposed to do? How can I make nitrobenzene from benzene? Do let me know, kids. I will do nitration of this benzene. I will do nitration. How, kids? Concentrated HNO3 plus concentrated H2SO4. These together will give you nitronium ion, NO2 plus, what do you call it? Nitronium ion. We will get nitrobenzene. Now from nitrobenzene, I want to prepare aniline. How I can prepare aniline from nitrobenzene? Is there anyone who can let me know how to prepare aniline from nitrobenzene, kids? Do the reduction. How will you do the reduction, kids? Do the reduction with tin or iron plus HCl. You will get aniline. Now my target is to convert aniline into benzene diazonium chloride. How to convert aniline into benzene diazonium chloride? Is there anyone who can let me know? Aniline to benzene diazonium chloride. Right now I have told you, do the diazotization. How will you do diazotization, kids? Do let me know. NaNO2 HCl ice cold solution, kids. That is going to produce nitrous acid HNO2. That will convert nitrosonium ion. Now that is nitronium ion. This is nitrosonium ion. Kids, have you seen one thing? That people are how much afraid of me? How much afraid of Baba? People are how much afraid of me? They are sending people for doing spamming at this much of time. Even 1 o'clock has been gone. People are sending people against Baba. See how much Baba is famous, so that Baba should not be responsible for giving you rank. You should not get selected. So people are sending these people. See, in my class only. See, at 1 o'clock, more than 1, people are writing, don't attend this class. This class is useless. But they are awake. See, they are awake. How much money they have got for this? Can you understand, kids? I don't know how much money they have taken, but see how many people are working against me. This is the fame. No one else should get this much of fame. See, kids. Now, I think whatever I have written, it's visible to you, kids. It is visible to you. Now, my dear students, if I am reacting this benzene diazonium chloride with, see what? If I am reacting this benzene diazonium chloride with HbF4, fluoroboric acid, its name is fluoroboric acid. I will get benzene diazonium fluoroborate. What is the name? benzene diazonium fluoroborate. Remember that. What is the name? What is the name of this compound? Everyone, can you see this memory chart? Benzene. Yeah, that's why people are feeling jealous of me, and that's why they are sending number of spammers. Just go in this class. Only in my class they are coming. Benzene diazonium fluoroborate. Now kids, two ways goes from here. One towards this nitrobenzene side and one towards this side. Now let's see. If I react this with copper and NaNO2, I will get nitrobenzene, copper and NO2 and heat. And if I simply heat it, I will get fluorobenzene. This reaction is known as Ball-Schiemann reaction. Which reaction, kids? This reaction is known as Ball-Schiemann reaction. Say everyone, Ball-Schiemann reaction. Ball-Schiemann reaction. Fluorobenzene, I will get fluorobenzene, kids. Fluorobenzene, I will get fluorobenzene, right? Fluorobenzene, what I will get? Fluorobenzene. It's looking fluorine or not? It's not looking. So let me draw. Now it will look fluorobenzene. Fluorobenzene, we will get fluorobenzene, right? Now, if I react benzene diazonium chloride with what? Cuprous chloride. Remember that Cu2Cl2HCl. I will get chlorobenzene. The name of reaction is Sandmeyer's reaction. What do you call it? Remember that. Sandmeyer reaction. Sandmeyer reaction. If I react it with cuprous bromide, Cu2Br2 HBr, what I will get? Bromobenzene. This is also Sandmeyer reaction. If I react it with CuCN KCN, what I will get, kids? I will get cyanobenzene. I will get cyanobenzene, benzonitrile, cyanobenzene I will get. All three are Sandmeyer reaction. Remember that. All three are Sandmeyer reaction. Now, there was one scientist, Gattermann. What is the name? Gattermann. So, if you react it with copper powder, HCl, you will get chlorobenzene. Here the yield will be less. In those two Sandmeyer reactions, yield was good. Good yield. In all three Sandmeyer reactions, good yield. Yield means the content, the production. But here, this is Gattermann reaction. Which reaction? Gattermann. Man of gutter, Gattermann. Copper powder, HBr. Bromobenzene. You will get bromobenzene, Gattermann reaction. Now, if you react with Ki, you will get iodobenzene. This is separate reaction. Now, my dear students, this cyanobenzene, if you react this cyanobenzene with what? If you react this cyanobenzene with what? SnCl to HCl. You will get imine CH double bond NH, unstable imine. Now if you do the hydrolysis, you will get benzaldehyde. And the name of this reaction you should know. If you don't know, Stephen's reduction. What do you call it? Stephen's reduction. Remember that. Its name is Stephen's reduction. This reaction, total reaction, this much is known as Stephen's reduction. Stephen's reduction. Now, my dear students, how to convert benzene diazonium chloride to benzene in one step? Just see in single step how will you convert this. It is a redox reaction. Redox reaction. How will you carry out the redox reaction? Just see, kids. If I use H3PO2, its name is phosphinic acid. Remember that. What do you call it? Phosphinic acid. Phosphinic acid. Let me write down once again so that you can understand, because it's very new name for you kids. Phosphinic acid. Phosphinic. Oh my God, what he has written. Let me see, kids. Phosphinic acid. Let me see. Yeah, he has written absolutely correct. Phosphinic acid. Its name is phosphinic acid. Its name is what? Phosphinic acid. Now, phosphinic acid will undergo oxidation. It will undergo oxidation to give phosphonic acid, H3PO3. What is the name? Phosphonic acid. Its name is phosphonic acid. Phosphonic acid. Its name is what? Phosphonic acid. So, phosphonic acid has converted to phosphonic acid. Phosphonic acid oxidation is taking place. So, this is known as reducing agent, mild reducing agent. So, definitely it is undergoing reduction. This is a redox reaction. In place of H3PO2, you can also use another thing. What's that? What's that? You can use another thing, that is, kids, glucose. So, glucose will undergo oxidation to give gluconic acid, and benzene diazonium chloride will convert into benzene, gluconic acid. In place of glucose, you can also use ethyl alcohol. Then ethyl alcohol will undergo oxidation to give acetaldehyde, and this will convert into this. You can also use SnCl2. It will undergo oxidation to give SnCl4. You will get this. Now, benzene diazonium chloride on reacting with warm water, H2O heat, you will get phenol, and phenol on reaction with zinc, Zn will convert into ZnO, Zan will convert into Zanu, and then this will convert into benzene. Now, this chart's name is diazo chart. Remember that? Its name is diazo chart. Whenever I say mind map, which mind map? Diazo mind map. You can call it even mind map. Which mind map? Diazo mind map. At least 2 questions you will get in your examination. At least 2 questions. Kids, is it visible to all of you? Only 20 minutes I am going to take. Daba, this slide is epic. Thank you, thank you. Thank you, really thanks. Only 15 to 20 minutes Baba is going to take. Now kids, at least 2 questions will be in your exam from here. At least 2 questions you will get in your examination from this. Now, I will give you one memory chart for applications of SN2 reaction, okay? Applications of SN2 reaction. Thank you, Deepika. Kids, and thanks for having faith on me. You see, number of spammers people are sending for me, you know. They are jealous of me because Baba is taking, you know, Baba is not only taking your classes, Baba is taking advanced IIT classes also. Offline advanced IIT classes. So number of people, they are always now kids, see, I am going to give you another one. Tamil Nadu Dreamers, thank you, thank you. Now let me give you one memory chart for applications of what? SN2 NSR, SN1, SN2 applications, right? Let me give you one memory chart for applications, right? Now applications, now memory chart for applications of NSR. See kids, if I take at this place, if I write over here CH3 Cl, CH3Cl, I have written at this place CH3Cl, or I can make hero as CH3Cl as hero. If I say CH3Cl, you are the hero at this place. So let me write down CH3Cl at the center, CH3Cl. Now, if I do the Williamson's reaction, very, very important. Without that, nothing is possible. Williamson synthesis reaction. Have you heard the name, kids? Williamson's synthesis of ether. Williamson's synthesis of ether. Have you heard this name? Williamson's synthesis of ether. Synthesis of ether. Then I will react this compound with, just see, I will react this compound with C2H5ONA and dry ether. So I will get compound like C2H5O and CH3. Got it, kids? This compound I will get ether as the product. Now after this, if I say I want to do exchange of halogen exchange, then there are 2 reactions for halogen exchange. One is Finkelstein reaction. What is that? Finkelstein reaction. What is that, kids? In this reaction, I will use NaI dry acetone. NaI dry acetone. Then what it is going to do? It will convert methyl chloride to methyl iodide. Now, another halogen exchange reaction's name is Schwarz reaction. Have you heard the name Schwarz? So I will use fluorides of what? In this, I will use fluorides of antimony, cobalt, Ag, mercury. These Florida, anti, cobalt, Ag, Hg. Okay. Florida, fluorides of antimony, cobalt, Ag, Hg. How will you remember this? How will you remember this? By seeing cobra, auntie is having hug with mercury. By seeing cobra, auntie is having hug with mercury. Okay, hug is mercury only, hug with Ag. Okay, will you be able to learn it? So you will get methyl fluoride. Methyl fluoride. Now, if I do the Hofmann's methylation, so I will use ammonia. So if I react ammonia, then what is going to happen? Ammonia's one hydrogen will react with this chloride, HCl will eliminate out, and I will get 1 degree amine, CH3NH2. Now 2 hydrogens are left. Once more I will do reaction with methyl chloride, one more SN2 reaction. Now once again HCl will eliminate out, I will get 2 degree amine, CH3NH. I will get 2 degree amine, kids. Now once again methyl chloride will react, and now HCl will eliminate out. Now I will get 3 degree amine. 3 degree amine means 3 times SN2 reaction has taken place. Now the lone pair is left. Once again I will react with methyl chloride, and finally I will get quaternary ammonium salt. I will get quaternary ammonium salt. Now kids, how many times SN2 reaction has taken place? Just see NCl. Now how many times SN2 reaction? Once SN2, second times SN2, 3 times SN2, and this is the 4th time. All these reactions are known as Hofmann's methylation. What do you call it? Hofmann's methylation. Hofmann's methylation. You are able to understand. Let me see whether it is visible or not, kids. Do let me know it is visible or not, kids. Thank you, Deepika Kumarla. Mercury is Hg. Teju, mercury is Hg. Hg is mercury. Now, is it visible, kids? Is it exactly visible to all of you, kids? Let me complete it. Now, first of all, do let me know it is really exactly visible to all of you, kids. Everyone, just to let me know. Thank you, kids, and thank you, Deepika, for understanding me. Really thanks. Let me have a sip of water. Now, kids, these memory map, mind maps, earlier I was giving and too much charge was taken for these memory charts. Now I am giving these memory charts for free of cost. You have to share this thing to everyone, what I am telling you, but don't give to everyone. Now see, kids, Hoffman's methylation I have told you, this I have told you, this application I have told you, this application. Now the most important, reaction with ambidentate. If I react it with KCN, remember that K positive, CN negative. What type of bond is there in between K and CN? Just see what type of bond, kids. What type of bond? K positive, CN negative, ionic bond. Now this negative charge is on carbon. Carbon is saying I will donate electron, nitrogen is saying I will donate. So that's why it is an example of ambidentate nucleophile. Ambidentate. What do you mean by ambidentate nucleophile? When both are having donor sites, but any one is donating. This casein was the reagent, but cyanide is the nucleophile. So carbon will donate and we will get methyl cyanide. So casino, sino, racino is the product. This is the product. Now see, kids, if I react with AgCN, now see what you are going to get. AgCN, remember that Ag is having pseudo inert configuration, so maximum polymerization. Pseudo inert configuration, you know, Ag, pseudo inert configuration. So this bond is covalent. Paget's rule, you know. So this is the donor one. Nitrogen is donor, so you will get isocyanide. There cyanide. Here isocyanide. Now kids, still not over. Just see. If you react it with KNO2, so K positive, O N double bond O, this will do resonance like O delta negative, N O delta negative, so like this. So oxygen will form the bond with that, you will get CH3 O N double bond O, methyl nitrite. But on the other hand, if you have done the reaction with AgNO2, so AgO and double bond O, this is the covalent bond. Now kids, see, here is the covalent bond, pseudo inert configuration. So this is more electronegative, its electronegativity is 3.5, its electronegativity is 3, less electronegative, so this nitrogen is the donor. So you will get CH3 N double bond O, coordinate bond O, nitromethane. Now, last reaction but not the least, if you react this methyl chloride with LiLH4, lithium aluminum hydride donor, so you will get methane. This is another memory chart. One more memory chart I will give you. If you give me some time, then the session will end. Yeah, Fajan's rule in chemical bonding, you're right. Kids, do let me know. Till now everything is clear, fit and fine. Do let me know, kids. Everyone. The class will be just for 15 minutes. Let me give you the memory chart, then it will get over. Kids, ready? Are you ready, kids? Because I have to give one memory chart for ESR, electrophilic substitution reaction of this chapter. Now I hope that everyone is ready for ESR. This was the NSR application. Now ESR. 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 Now kids, here is benzene. Here is benzene. I am going to draw benzene. This is the center of attraction. Who is the center of attraction, kids? Benzene. Now, the ESR are Hansa, HNSAA, H for halogenation, then N for nitration, then sulfonation, then Friedel-Crafts alkylation and acylation. Just see, kids. But I am having chlorobenzene because I am dealing with halobenzene. So here is chlorobenzene, okay? So halogenation, if I do the chlorination in presence of anhydrous AlCl3, then what I will get, kids? I will get two types of products. What are these two types of products? Do let me know, kids. Anyone? Any clue? Any idea? Two types of products. What I will get, kids? I will get two types of products. What are they, kids? Everyone do let me know. Tell me, kids, what two types of products I am going to get? I will get orthochloro and plus I will get para because it is ortho para directing group, anyone who is having lone pair, it is always remember that this is going to be ortho and para director. Remember that ortho, para director, that is OP director. Remember that it is OP director. This is halogenation. Now if I do nitration, kids, if I do nitration, then what I am supposed to take the nitrating mixture? Nitrating mixture is concentrated HNO3, concentrated H2SO4. In this reaction, HNO3 act as a base, and H2SO4 act as an acid. Remember that this is the question. Both together will combine to produce what? The reacting mixture as NO2 plus. What do you know? Nitronium ion, the actual attacking agent. Nitronium ion. Now product, you will get two types of products. What are these two types of products, kids? Do let me know. What are these two types of products? What will be these two types of products? Everyone do let me know, kids. Everyone just do let me know, kids. See, one will be chlorine and at ortho position nitro, orthochloro benzene, and one will be para because chlorine is ortho para director. This will be major, para will be major. Now if you do the sulfonation, if you carry out the sulfonation, what you will use? Concentrated H2SO4, or you can use oleum. What is oleum? H2S2O7. This is known as sulfonation. Kids, then what you will get? Once again, two types of products you will get. What are these two types of products? Just see, kids. These two type of products will be in one case SO3H will come at ortho, in another case SO3H will come at para. Para will be major once again. Now if you do Friedel-Crafts alkylation, then what you will get, kids? Friedel-Crafts alkylation. Suppose you have done reaction with CH3, CH2, CH2, Cl. Then what will you get, kids? Then again two types of products you will get, kids. Then again you will get two types of products. Now what are these two types of products? Let's see, kids. One you will get chlorine CH3. This is isopropyl because rearrangement will take place, and the para one chlorine para CH3. This one is major one, kids. Now how the reaction has taken place, just see, anhydrous AlCl3 will react with this chloride and take away this chloride. You will get carbocation, and whenever the carbocation is formed, always think about rearrangement. 1,2 hydride shift will take place, and you will get CH3 CH plus CH3. Now Friedel-Crafts acylation. If you do Friedel-Crafts acylation, kids, what you will get? You will get two types of products, kids. What are these two types of products? Just see. One, first let's see with whom you are going to react. CH3 COCl anhydrous AlCl3. So you will get Cl COCH3. Steric hindrance is too much, so the para one will be major. So this is electrophilic substitution reaction, kids. Is it visible to all of you? Just to let me know. Is it visible to all of you, kids? Kids, do let me know. Everything is clear. Is it visible? Everyone, just to let me know. Is it clear to each and everyone? Are you able to understand it, kids, what I have written? How are these memory chart, kids? How are these memory chart, kids? Now, kids, you are liking these memory charts. They will help you a lot to give you the rank like Suez Arora, Mehak Arora, 3rd Ames rank, 4th Chaitanya Mittal, 4th Ames rank, and everyone, kids. If I say the 1st rank holder, Yadav, Tanishka, all these kids, they have got rank because of these memory charts. Kids, these memory charts are brilliant memory charts, very, very important memory charts, kids. Now see, it's looking like that somebody has made through highly technician. Highly technician means somebody who is too much pro in the techniques. That teacher must have made it. It's looking like that. But your simple, your teacher, simple Baba, has made all these kids. Are really they are good kids? First of all, do let me know. They are really good or not? Always do revision in the morning, then directly they will fit into the hippocampus. They will fit into the hippocampus. Directly they will go into the hippocampus, kids. Teju, thank you, Teju. Thank you very much. Now kids, let me give you some conversion chart so that easily you can do your NCERT questions. Let me give you some conversion chart, okay? This is going to be the last one. Just 5 minutes more. This is going to be the last one, kids, okay? See the memory charts I am giving you. See this memory chart. After this, I have given this one. After this, I have given this one. And the last one, today's. Then the chapter will be full and final. Conversion chart. Let me give you conversion chart. This is last one. Conversion chart. Now, let me tell you kids, the conversion of the basic of this chapter. Who is the basic? From where I am going to start? Just see from where I am going to start the conversion. The most important thing is CH3 CH2Cl. Now I have reacted this with C6H5ONA. Its name is sodium phenoxide. Remember that, sodium phenoxide. Now see, in the presence of dry ether, which reaction is this? If anyone is asking which reaction is this, kids, then you have to say this reaction is Williamson synthesis of ether. What you will say, kids? Which reaction is this? Williamson synthesis of ether. This is what? Williamson synthesis of ether. Remember that. Williamson synthesis of ether. Williamson synthesis of ether. Remember that. Very, very important reaction. Williamson synthesis of ether. Remember that, kids. What is the name of this reaction? Williamson synthesis of ether. What is the name of reaction? Williamson synthesis of ether. What product you will get, kids? Your product will be, this will react, this will react, this will react, NaCl will eliminate out. Now what do you get, kids? Our product will be anisole. What do you call it? Anisole. Very, very important. Anisole. What do you call it? Anisole. Remember that. Anisole. Now, anisole on doing the cleavage with HI. Cleavage with HI. If you react it with HI, remember that. First, what will happen? This is acid. It will throw its H plus. That H plus will go to the lone pair. What will you get? One intermediate. Very, very important intermediate. Oxygen will get positive charge. and you will get CH2, CH3. Now oxygen will say, I can't tolerate this positive charge. This is intermediate, highly unstable. Highly unstable. So I negative will come and take away the bond formation will take place with this. This will form phenol. This will give phenol, and that will form CH3, CH2I. Now, if you react phenol with with whom? If we react phenol with zinc dust, what will you get? If you react phenol with zinc dust, kids, what will you get? Do let me know. Zinc dust. Zinc will take away oxygen and ZNO. You will get ZNO, and that will get converted into benzene. Remember that. This will convert into benzene. Now, if you do the reaction of benzene with chlorine, Cl2 anhydrous AlCl3. What do you call this reaction? This reaction will be known as Friedel-Crafts alkylation. What do you call it? Friedel-Crafts alkylation. Remember that the name of reaction is Friedel-Crafts alkylation. No, it's not Friedel-Crafts, sorry, halogenation, ESR, halogenation, sorry kids, ESR halogenation, ESR halogenation. It is known as ESR halogenation. Remember that, ESR halogenation. Now what will you get, kids? If you do the ESR halogenation, you will get chlorobenzene. Remember that, chlorobenzene. Now today I have told you the reaction of chlorobenzene with NaOH, 623 Kelvin temperature, 300 atmospheric pressure, H plus. This is the first, this is the second. The name of this reaction is Dow's process. Remember that. I haven't told you the name at that time. This is known as Dow's process. What is the name, kids? Dow's process. What do you call it? Dow's process. Dow's process. The name of this one is Dow's process. What do you call it? Dow's process. Dow's process. And you will get phenol. What do you get? Once again you will get phenol, kids. Phenol. I hope till now it's clear, kids. Till now it's clear. Is this much clear to all of you, kids? Do let me know. Each and everything you are able to understand, kids. Yeah, ethoxybenzene is phenol. Jyoti, oh my god, Jyoti is there. Welcome, Jyoti. Clear नहीं दिख रहा है. How is it possible clear नहीं दिख रहा है? Kids, do let me know. I think it's clear. Yeah, this is useful for JEE students, NEET students, for everyone, kids. It's very clear. See, kids, whatever Baba is giving you, Baba is telling you, that's clear, 100% clear. How it can't be clear, kids? How it can't be clear? It's 101% clear, kids. Now, kids, I think that everyone got it. Baba is pro in technology also, not? Jyoti is writing, please check in current slide, sir. Which slide, Jyoti? ethyl chloride, ethoxybenzene, HI ether, phenol. Where? Where, Jyoti? I am unable to understand which thing you are asking, Jyoti. What thing actually you are asking, Jyoti? This one, which one? Yeah. So what's the doubt, Jyoti? What's the doubt? Where is the doubt? Oh, right. You are right, Jyoti, you are right. It is not anisole. It is phenitol, kids. This is not anisole. Phenitol, you are right. Because OCH3 is anisole, that is small. OCH3 anisole, this is phenitol actually. You are right. Phenitol, kids. It's phenitol. It's phenitol. Let me write down on the next page what's the difference between anisole and phenitol. Let me tell you, kids. See, this chart also I will give you. This chart also I am going to give you, kids. See, here in this chart, very important thing, kids. See, two ways, two reactions. See to it. I will write two types of reactions. They will help you. Kids, one point is clear. Okay, first let me clear that point. What Jyoti has asked. Kids, let me make that point clear. What is anisole and what is phenitol? Let me write down. Kids, let me tell you. See, if I write down like this, OCH3, and if I write down like this, OCH2CH3, who is small? This one or that one? This one is small. That's why its name is anisole. And this is tall. This is tall, so phenitol. This is the trick made by me only. Now it is clear, kids. So I have written there wrong. This is taller, tall, so phenitol. This is small, so anisole. That is the trick. Small, tall, tall. Kids, clear? And Jyoti, thank you. Jyoti, thank you. Kids, just 2-3 minutes. 2-3 minutes. Now it's clear. Everyone, just to let me know. Now it's clear. Clear, kids? Anisole and phenitol. Kids, do let me know. Is it clear? Thank you, unknown user. Now, let me write down two reactions, just two reactions, so that everyone should feel the best. They should get the best feelings. Just see what I was going to tell you, kids. Here, one reaction at this place. These two reactions already I taught you, but let me tell you, kids, over here already these two reactions I have told you, kids, in the alkene chapter, but I am telling you over here so that you can always keep it in your brain. These two reactions, just see what is the difference. I am trying to put it like that so that you can always remember. Because in these two reactions, everyone is going to do mistake. Just see, in these two reactions, most of the kids, they are doing mistake. You should not make any mistake. That's why I am telling you these two reactions. Just see. See, kids, if I write CH3, CH2, NEX, and CH3. This X, chloride, bromide or iodide, but not fluoride. Then what you will get, kids? If I react with KOH alcoholic, heat, I will get two types of products, CH3, CH double bond CH, CH3 plus CH3, CH2, CH double bond CH2. Now see, kids, this is a alkene, this is also alkene, but see the difference. It is having two sides alkyl groups. This is one alkyl group. This is one alkyl group di-substituted, but it is being just mono-substituted, one bigger group mono-substituted. Are you getting my point? This is being di-substituted, and this is being mono-substituted. So remember that, my dear student, di-substituted is known as ZJ product. What do you call it, kids? This one will be known as ZJ product. What do you call it, kids? Do let me know. ZJ product. What do you call it? This product will be known as ZJ product. What? ZJ product. What do you call it? ZJ product. ZJ, and this will be known as Hoffman product. What do you call it? Hoffman. This will be known as ZJ. Let me write down ZJ product. That will be known as ZJ. ZJ product. ZJ. Oh, what it has written? I have written ZJ. ZJ is also known as JETSEB. The another one is Hoffman. What, kids? Hoffman product. Hoffman product. That will be known as Hoffman product. Now, kids, see the same reaction. If there would have been fluoride, then the things would have got changed. See, CH3, CH2, CHF, CH3, NaNH2. Achha, let me write down. This was the major product. This was the major. 80% was this product, 80%, and that was just 20%. Now here, NaNH2, soda amide. Now heat, what will you get? Product will be CH3, CH, double bond CH, CH3 plus CH3, CH2, CH double bond CH2. Now this time this will be just 20% and that will be 80%, kids. Now once again this is ZF, that is being Hoffman, but this time it is minor, that is major, because, kids, here the rate determining step is, for this reaction, the rate of reaction is directly the reason. Let me tell you the reason. This carbon ion is going to be 1 degree and this carbon ion is going to be 2 degree, and this is a more stable carbon ion. So what I want to say, when fluorine is leaving group, then rate of reaction is directly proportional to the stability of partially charged carbon ion in transition state. Now it got completed. Completed kids, completed, done and dusted. Done and dusted kids. Is it visible to all of you? Clarity is there in this chart. Time up, 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 up. It's completed kids. It's completed. Do let me know. You are able to understand this one, last one. It's clear or not? Now over and out, everything I have explained kids. Each and everything I have explained kids. So kids, this is the whole chapter got completed. I have taught you each and everything, done and dusted kids. I haven't skipped even a single point. I have told you each and everything. Wow, Madhumita, you are really fantastic. Telugu industry, Monica, unknown user, prawn, Telugu, Madhumita, thank you kids, thanks a lot. Thank you kids. Deepika, Komarla, thank you. Monica Goda, thank you. Yeah, Ria 2.0, thank you. Okay kids. So bye to all of you. God bless you. Love you kids. We'll meet you again in the next session. So stay tuned. Good night. Bye bye to all of you. God bless you. Love you kids. Right? Okay kids. Namita Madhu, thank you. Lakya, thank you. Yeah, definitely. Praveen, I will share. Definitely, I will share. Definitely, I will share. Bye, Madhumita, Teju, Telugu, Lakya, Deepika, everyone. Bye to all of you kids.